working your way down. I mean, I'm guessing the battery reset's not in the driver's door module, so that's probably pretty low on my list of options. But you don't know until you hit all this stuff. And then good luck, I always work on everything, so good luck remembering next time I get one of these cars and I got to do this. Here's an ABS module. So if you can't find a reset in your aftermarket scan tool, don't assume the tool is the problem. Many manufacturer applications don't support a scan tool reset. Code current adaptive resetting may work, but often refer to the battery disconnect alternatives. So here in this case, the ABS module actually has what? A reset ECU. You don't know if it's there until you look. How many of you knew you could even reset an ECU with a scan tool for an ABS module? Why would you want to? I don't know. Apparently you need to in some cases.
What's this bleed brakes? So when you open the system, you got to go into this bleed brakes?
It depends. I'm going to remember who this is. This is...
What, is it just bleeding the ABS so that...
Yeah, it depends on the manufacturer. Some of these, you actually use this and you have someone you open the bleeder valve and hit the command and it pumps it through. Other ones are like GM where it's an internal ABS bleed. So we see both on this function. I'm not sure off the top of my head because I didn't take this capture which this car does.
I've actually had to put applied voltage to some of these GM ABS units at the ABS function, give it 12 volts to get fluid to pass, to get the little brake light off. There was nothing really wrong. It just, whatever reason, there was something in this. Right.
But yeah, I mean, why should I have to reset and initiate an ABS module?
Could you just do a global and reset everybody?
You could. Most likely that would work, but then you might be relearning Windows for the next half hour.
Yeah. Right.
But you're right. Many times my only option is is resetting window memories because I do have to disconnect the battery, or maybe I can just pull a fuse for a particular module. Keep in mind, there are modules that get fed by more than one fuse, so that can also create issues more than it solves. That's why I like the battery disconnect. Plus, if you tried looking for a fuse lately and what it goes to, much less the fuse box, I mean, you can waste a half hour just trying to get a picture of a fuse box and what fuses go where. I can learn the windows in that time.
Right.
So adaptive clearing, this particular vehicle controls clears the automatic transaxle adaptive values. So all different modules have different adaptive values that may need to be cleared.
Is that Autel there, or is that?
This is Snap-on.
Oh, that's Snap-on?
Yeah. And again, this is also another option. If I reset the adaptive values, do the symptoms get better? Do they get worse? What happens? So maybe I'm going to do this as a diagnostic. Maybe the customer complained the transmission wasn't working right, but it seems to work fine now. Well, let me clear the adaptives and see if the problem comes back. Maybe the computer's hiding it. Battery disconnect alternatives, module isolation, just disconnecting the module or just pulling the fuse to that module. I already kind of touched base on that. Again, it's a simple choice. Which do you want to do? What's easiest? What do you have access to? There's not a one size fits all. Full battery disconnect, I got to think about battery relearns. The other issue that we have on
Brian, I'm sorry, battery disconnect and reconnect. I saw it's happened on the GM on it makes the electric power steering module go bad.
I've never had that on one. Okay.
Yeah, we did one and I took it back, and we don't have the power steering.
Try disconnecting it again and try again.
Yeah, we did.
Oh,
ended up we have to buy the used one, put it in.
Huh.
Yes.
That's weird. I've never had a problem with the power steering. The OnStar on some of these has a backup battery for OnStar, and just like Mercedes has two batteries. So if you short the cables together, when there's a backup battery, you're going to have some issues.
Yeah, I have a friend of mine work for Carlsbad Lexus. He see a lot of weird thing after disconnected, reconnected battery. So they don't recommend to do that.
Yeah. And see, I fixed a lot of Toyotas and Lexuses by disconnecting the battery. Like the navigation doesn't work, disconnect the battery. And
Yeah, they blow up the the navigation.
but yeah, I agree. I don't like to disconnect it just because. But if I'm trying to solve a problem, I figure things are already screwed up. Let's see what happens.
Yeah, that's the last choice.
Yes, the Hail Mary.
Yeah.
How about disconnecting the battery, putting a light bulb as your load, and
Yep.
wait until that thing turns off on your backup battery
Yeah, but then you've drained the
instead
backup
of
battery all the way
shorting
down.
them
At
out.
least you're not shorting it. And again, a light bulb would tell you if you have a backup battery, right? Because if there's no light bulb, then hey, it's safe to put the cables together and discharge the capacitors. Volkswagen takes over 20 minutes to discharge the capacitors to dump the memory out of it. So I've had them where it doesn't work. Well, I'm going to put the cables together longer and go have lunch. Come back and now things work. So sometimes when you don't have a direction, a little patience can help a lot. So one alternative method is the previous pages to combine power removal with single module with shorting only that module. So shorting just the power and ground input to the module with it disconnected. This method has the advantage of fuse removal and also allows you to discharge the capacitors in that module. So that's something else. So maybe on the power steering module, maybe disconnecting it and jumping between the power and ground input with it disconnected might have discharged the capacitors and got it back. Who knows? I mean, we've all had modules go away for no reason.
So you're finding what pin is in the module being powered up, and you're jumpering it at the module with the connector unplugged.
With the connector unplugged the module, that's not if it has a battery in it, but yes. If I disconnect the module, take it off the car, then just jump for the power, the positive to negative for the power in on the module. With
At the pins. Yeah, okay. I haven't done that one yet.
Yeah, but you're going to discharge the capacitors that way
Right.
without dumping the whole car. So, there's probably many times you'd never do this, but it's something that you've already got access and it's already there. And you froze up on me, Daniel. So here's a no communication case study. 2007 Suburban came with a complaint that the driver's window functions were inoperative. Code shown, should be to the right, were found in the driver's door module. So I got a whole bunch of internal switch malfunction and a patch department lamp control circuit code. So I got a whole lot of B codes, only one U code. So all of our network codes are not necessarily U codes, and B codes are not necessarily network codes, but we should definitely take a look at this. So this was pretty simple. The switch was wet, and the customer admitted that the window was not fully closed during the previous night's rains. The solution was to replace the dehumidifier in the vehicle with the doors and windows closed. After a few hours, all the door functions returned to normal. However, we're not quite done. Codes were cleared. After clearing various functions and checked again to be sure the window switch survived the moisture, the only code that came back was the U0140 for lost communication with the BCM. The scan tool was used to communicate with the BCM, but nope, can't talk to the BCM. So easy's always good. The BCM is in the middle of a splice pack for the GLAN network and is nowhere near the driver's door module. This indicates that the GLAN is not the cause. Communication faults, nevertheless, are an open between BCM terminal M of the splice pack. Certainly, this could cause the problem. But before we go down the rabbit hole, let's do a BCM reset, both because it's good discipline and because GM BCMs get locked up. So here, disconnecting the battery, reconnecting it, the BCM's back and the car works.
Because
So
they detect the power switch window have the issue, and then the BCM lock up by them
Yep.
itself.
yep.
Okay.
So just like sometimes you ever have your printer not talk to your computer anymore, even though everything's plugged in. I think
Yeah.
you turn your computer, turn it back on, and now it can talk to the printer again. Or is that just me that has to do that every couple of weeks?
It's very,
I
that's
got to
very-
do that with the router here at my place. The router
Yeah.
that well, really it's a gateway and a router, but I have to do that with it.
Yeah, that seems like an easy fix though.
And I see Tony is busy at the hospital. You no longer have the comfortable chair, I see.
I don't, and I wanted to ask you, can I still?
Well, looks like you're bandwidthing out on me, Tony.
He's out.
Okay.
We got a bad network though.
Yeah.
They will reset.
Much.
All right. I think we kind of I don't think he has enough bandwidth there. So
I'm left.
16 pin DLC, power pin 16, ground at 4 or 5. Other pins are used for specific functions depending on the application. So gateway vehicles with DLC termination, BMW DLCs have a protective cover with 3 terminals. In this case, covering the shorts terminal B plus to terminal 7 and 8 through the resistor. If there's a problem with this cover or anything related to this shorting strategy, the manufacturer will be nice enough to give you a code to clear it. Code for it. The only thing is you may need to watch out for, there should be a cover, but it's missing. So here's an example of a car that runs fine, but we have a code, and the code's because the cover's not there. So if we ever taken a scan tool off and moved the car, then you put the scan tool back in, and then you pull codes again or something like that, and maybe you drove around with the cover off while it's in the shop.
How does it know the cover's plastic? It's insulated.
No, it has this resistor right here that you can see in the picture that shorts 3 of the pins.
Well, I see that, but what, the cover has some type of bus in it?
Yeah, it has wiring in the back side of it here, connecting the pins. You see the 3 pins here?
Yeah,
Yeah.
I see them.
Yeah, so it's connected on the back side through the resistor.
So what that
So
for,
the third
Brian?
pin gets tied in when the cover.
Yeah, I don't know why they do it. They just do. You could say it's protect the network. You could say it's for, whatever. I don't know. But they do, and they set a code if it's not there. And I hate to see someone waste their time because they drove the car around the shop without the cover on. And then now we got this new code and you're trying to fix a car. Think about it. You do a diagnosis, you're waiting for a part, you pull the scan tool, park it, come back to it later. And now you got this new code when you're going to do stuff and you're like, whoa, now what's going on here? So.
But did it trigger the milk light on or no?
No, it should not.
Okay. So don't worry about it.
Yeah, exactly. I like that.
This guy, man.
Yeah, you go to generic, you scan it, and
Yeah,
you don't see any code, so don't worry about it.
that's it. So here's a DLC resistor example. Here's a parallel fixed resistor between the diagnostic CAN circuits between the gateway. So if we look at terminal 6 and 14 at the DLC at the top of the picture, we're going to see this terminating resistor off to the side. is wired in parallel to the DLC. Why is it there? Because we need to have two terminating resistors. Your scan tool doesn't have a terminating resistor. Therefore, one is in the gateway module. The other one is freestanding, parallel wired into the wiring going to the DLC.
So that's the one that has 120 ohms.
Yep, 220 ohm resistors. So that's one.
That they call connection high and low, right?
Yep. Yeah, so CAN high and CAN low are connected through these terminating resistors, and we'll get a little bit more into them in a little bit. So they're not completely isolated. They're parallel to each other through 220 ohm resistors. So when we look at our network wiring, you don't have to think about which network is used for communication. U-codes will point out the fault. For non-communication faults, you can use the topography screen or the wiring diagram to see which network is communicated to a module. However, there are times when a module is connected to more than one network, and it can be difficult to sort out. So we may need to read, like we have here, where we have the different networks. And where that can be important is if I look at here, this is a CAN vehicle, an early CAN vehicle, Chrysler, and it does a handshake on the SCI network. And then it talks and shares information on the CAN network. So that's why a lot of times on these Chryslers, you get the VIN right away, but then there's a delay before it talks to everybody. It's switching networks. On the earlier systems, they may have switched from SCI to the ISO 9141. So you'd have two networks on the same pin. And that's why if you're working on something like a 2000 Chrysler or slightly after that, if you ID as a generic vehicle, then you ID as manufacturer specific. It takes a little while to get there. And then you try to go back to generic and it won't do it. It'll say no communication. But if you unplug the scan tool and try over again, now you can talk to the generic side again. The reason for that is it's actually using two different network protocols, one for generic, one for enhanced.
Same wire.
What's that?
The same wire.
Yep. Same wire. So that's kind of crazy, isn't it? Two networks, one wire. We're going to handshake with one and talk with the other. Yeah, in this case, it's two different wires in this example, but I can't talk on CAN if my SCI network's down. So I could have generic communication because generic communication just goes through CAN. But I can't get to the manufacturer side on this Chrysler unless I can do the handshake through the SCI network.
So basically you have to unhook the connector and then hook it back and talk again.
Right. And this right here could create a neat issue because this is where the cheap $80 code reader can talk, but your $10,000 Snap-on can't. It can on generic, but not on manufacturer. Why? Because there's a problem with the SCI network, so it can't do the handshake to tell it to go talk to CAN.
That's
Isn't
weird.
that crazy?
So you should always have a cheap $80 code reader around.
Yeah, sometimes it's kind of interesting. Or kick your fancy one over to generic. That's why I always say, if you can't talk to an ID and it doesn't talk to generic, because people go, well, that's the same thing. Not necessarily. Different rules.
Right.
Different parts of the computer. Different handshakes.
And I see this too. Yeah, you're right. I see this type of shit.
Right. So, again, does everyone do this? Thank God, no. But do some do it? Is it something that we should keep in the back of our mind of a possibility when we're dealing with a problem? Yeah. How do we find it out? A little research. So then we get into the diagnostic process. So we're going to talk about how to identify the type of fault, research, testing tools, scan tool functions, direct circuit testing, and some fault isolation techniques. And so when we talk about research, That's huge. Everything, I mean, I could do slides on just research, everything from TSPs to IATN or diag.net to what is the neat thing that Snap-on is telling us now. So it goes in. So, you know, tools, am I talking basic tools or lab scopes? What am I trying to prove? You know, and so we're going to go on it a little bit more. So, but why diagnose a network in the first place? No scan tool communication with any module. That's a good reason. No scan tool communication with one or some modules. Okay. One or more systems don't respond to an old codes request. System lamps or messages are displayed for systems with no codes. One or more systems operate unpredictably or erratically, and one or more systems are inoperative. So these are all good reasons to diagnose a network. Am I going to diagnose the network the exact same way, regardless of which one of these I have? No, of course not. If I can't talk to one module, I'm going to diagnose that very different than if I can't talk to any modules. I'm going to diagnose that different than if I can't talk to 5 modules, right? So depending on what I have, I'm going to have different diagnostic scenarios that I'd want to go through. So for example, no communication with any module. Do I have power and ground at the DLC? Do I have a module that is stuck? They call it latching, either a power or ground. In other words, do a global reset. Can I get it to unlock? If it's an open circuit, do I have a bad DLC at the backside? Do I have wiring? Do I have open pins? Do I have a gateway not connected to the DLC or networks? Or do I have a gateway? Network short to power or ground. Do I have a bad scan tool? Certain opens must be between the DLC and the rest of the network, or just on either side of the gateway in order to create a problem. So again, I got to do some research here. But if I can't communicate with any module, I'm going to start at the DLC and work my way that way till I get to my first module. So the next question is the network open or shorted? If it's open, that's a bad connection. If it's shorted, then is it shorted to power, shorted to voltage? The easiest way to tell if a network is open or shorted is with a lab scope. And, you know, in a quick reference, if it's CAN, I should have 2.5 volts on each wire and then see a signal. But keep in mind, my scan tool is also a signal generator, isn't it? Doesn't it initiate communication? So if I watch with a lab scope, when I activate my scan tool to talk to a network, can it put traffic on the network? If it can, it's an open. If it can't, and all I have is a flat line, the network's shorted.
But where are you putting your oscilloscope?
I am putting it right on a cool tool I'm going to show you maybe after lunch, which is an OBD2 breakout box. And that goes between my scan tool and the
So basically,
DLC.
you're
Yeah, it goes between the scan tool and the DLC and has the banana plugs for all the pins I can
right.
plug the scope right into.
Well, you could just back probe the DLC then even.
Yeah, but when you get old and fat like me, I like the tool that I can sit up and plug it in up top.
Do they sell that tool
Yeah,
or you
yeah,
make it, Brian?
AES.
AES Waves sells them up in Fresno.
Right.
$200
Okay.
bucks. That's $200 bucks.
How much? Oh, it's pricey, huh?
Yeah, but I use it for all kinds of stuff. I use it when my smog machine's not talking to a car because I can tell if the smog machine's trying to talk or if the smog machine's locked up. I can do all that really quickly because it has LEDs. I'll show it to you coming up.
Oh, so you can connect to the hard wire, not the wireless, to the smart machine. That's what you tried to do.
Yeah, yeah, you plug right in the DLC. I'll show it coming up. It'll probably be after lunch, but I'll show it to you guys.
Hey,
Okay.
that's probably like along the lines how they clean pipe. They had a little device like that.
Very similar. So
Well, I
no
mean-
communication with some modules. DLC terminal contact because we might have multiple modules. So can I talk to modules on one network but not another? Network short to power or ground, module latching, gateway not connected, Certain opens must be between the DLC and the rest of the network, or a scan tool problem. No communication with one module, open network, module power ground, wake up circuit, module fault or module not equipped, system misidentified on the scan tool. In other words, we clicked the wrong button. We went through the menu so fast. Whether that's a year or a model. I've certainly worked on cars where I had in my head, I'm working on one model and it turns out to be another. You know, so.
I've had some models where I couldn't get in, so I just picked different years and something similar, and then they get in.
Yep. And that's an old trick. And it works. And here's the rule. If you can talk to it, the data you get will be valid. So even if you lie about what year it is, you lie about what model it is, if you're able to talk to it, the data you get will be valid.
Okay, that's good.
So that's an old school GM cheat, but it works.
Yeah, it works.
So network fault to likely cause. So again, part of what we'd always put in the book is try to give you guys some assistance when you have this stuff back in the shop. So we do some fault to likely cause. So short, intermittent, or codes wouldn't be retrievable in a module. So in other words, if I have a shorted network, it has to be intermittent or I wouldn't be able to get codes because the network would be shorted. If I have a voltage drop or ground voltage drop causing a loss of communication during electrical loads, high cranking, turn the blower motor on, put the windows down, short in the circuit. So maybe my can high and can low are shorted together. Circuit noise induced from other faults, like a failed alternator. We had a Toyota or Lexus that the alternator was putting enough RF in to cause the computer to go nuts because it was putting in enough RF into the network. And I haven't seen that in years. And it was really.
What led you to that? I mean, you're trying to diagnose a network fault. You were like, my source of power is dirty. I mean, what?
The shop had already replaced like everything else and was pulling its hair out. It was like, okay, time to start looking at things that just are not normal. Looked at the location of the charge wire compared to the network wires. They were next to each other. Let's look.
Disconnect the charge wire and then try to communicate?
Did that. The first thing we did was look for AC voltage in the system. But yeah, we did disconnect the alternator and the other problem went away. Cool. So open circuit, but only if the code is set in a module beyond the open. In other words, all the modules that can't communicate that are setting codes after the open, they're not sharing those codes with you because there's an open. So you need to have another module complaining that it can't talk to it. So U codes for shorts and opens, actual shorts or opens per code definition. Short in a module, short being a general term that covers a module that's holding a circuit either high or low, right? So if I close a switch, technically it's shorted. We all good with that definition? Just like, so what are my switch positions? Open and closed or shorted. So if a module has a transistor that sticks, which does happen, we've shorted the network. However, a lot of times disconnect the battery, the transistor becomes unstuck because there's no longer current flow. Open in a module, which includes some networks that cannot pass directly through modules. So missing message, tattletale U codes. The great thing about U codes is the module with the problem doesn't set them. So for example, if someone's internet freezes, we can all see that that person's internet froze. When their internet's no longer frozen, we can see it's not frozen. However, the person whose internet is frozen, I should say their video is frozen, they have no idea. as far as they're concerned, everything was just fine. So, tattletale codes, it sets for everybody else. And so for parallel star networks, an open leg or poor connection could be a dead module, might not have a wake up signal.
Go to the bathroom.
What's that? Other U codes, erratic communication, open termination, twisted pair, short to itself. So if it's erratic, that's probably electrical noise or interference. Open termination, the code's not kidding. It could also be an open circuit near a termination resistor. And a twisted pair short to self, simply use an ohm meter to verify resistance, or easier yet, use a lab scope. I'm going to show you how to do both those. We also may get clues on the dash. Chrysler used to say no bus on the odometer. Toyota here says it's E outside. Let you know there's a network fault. Of course, there's some other lights on the dash also, and it kind of looked like it was Christmas time, but the E outside was a clear sign that it's a network fault. Just like Chrysler's used to put up no bus. So just like any diagnosis, we do it in stages. So our first pass is the customer interview. That's what the service advisor doesn't ask the customer questions. Then it's on us to try to verify the complaint. Then we're going to use a scan tool to attempt communication and try to retrieve codes from all the modules that will talk to us. And then do our research. TSBs, is there calibration updates, network topography, construction, bias voltage, what's the protocol, termination, splice, locations, etc. Let's learn all about this car.
Identify.
Identiguess. Then high-level diagnostic questioning. Does the car start and run? That sounds silly, but it's huge. If I have network faults and the car starts and runs, or I should say I have no communication, and the car starts and runs, it's probably a scan tool communication problem and not a network problem. Car starts and runs. Is there lights on the dash? Do all the systems operate properly? If I have a car starts, runs, and there's no warning lights on the dash, but my scan tool can't talk to it, I probably got a bad DLC or a bad gateway or some kind of pin fit or wiring issue there. The car's working fine. Can the scan tool communicate with all the modules? Make a list. And this is important because as you fix things, you want to repoll and see if you got new modules. Are there any codes in any module? What is the normal at-rest voltage and voltage range for the network? Goes back to our protocol. Are termination resistors used? If so, where are they? So we'll find out that not all networks use termination resistors. Certainly CAN that goes to the DLC does. Even with CAN that goes to the DLC, they do not all have permanent termination resistors. Some of them are only activated once the key is turned on. So I can't test them. Others have 3 instead of 2 or 1 instead of 2. So we've got some nice variations out there because we don't want to do anything too consistently because then we could actually learn it and remember it. And what fun would that be? Are any aftermarket devices tied into the related networks or systems? Which today means, is there any aftermarket devices on the car? Because the guy with the test light or the power probe is looking for anything with voltage to tie into, isn't he?
Yeah, the stereo shop.
Exactly.
Stereo shop, they always tie into like network wiring.
Right.
It's the ground when the key's off, but it turns hot when
Right. And that may be for that new backup camera that they put in, or the new front camera they put in, or any other accessory that they decided. So the customer interview, for example, 2007 Highlander came in with a complaint of no HVAC connections message on the multi-display in the center of the dash. And the air conditioning is stuck at the cold set in a high airflow. You could spend an eternity diagnosing this fault, but the interview flushed out it occurred right after the aftermarket radio had been installed. Is that a pretty big clue?
Mhm.
Yes.
Does that mean we probably need to take the radio out and look behind there and take a look-see?
Put it back to original radio.
Yeah, that makes way too much sense, though.
No, I need 170 decibels of bass.
Right. My neighbors love me. Other unexpected interview lessons, driver position. Right? So maybe I got a seat harness, right? I got a module under the seat, and either I move the seat because I can't fit in the car, or maybe the spouse brings the car in, and they might be of a different height than the person who normally drives the car. So now the seat's been changed and is no longer in the position that's causing the problem. Or it only happens when my wife drives it. It never happens when I drive it. And I'm 6'4" and she's 5 foot. Again, clues, codes after start. When codes set a key on, it's a hard fault. Diagnosed pretty straightforward. But if it's after start, did we lose battery voltage? Do I have a bad battery? I've had bad batteries that start the car, but reset modules and cause communication codes. Accessory usage, and I mentioned this earlier, does it only happen when I turn the AC on or the blower motor on? Because maybe I have a bad ground that's shared by several modules. And now when I turn that on, we have too much voltage drop on the ground and the modules go offline, setting a network fault. So this is important stuff to not only look at or ask the customer about, but also think when I can't duplicate the problem. Maybe I need to start turning stuff on. Maybe I need to kind of move the seat. Maybe I need to do some stuff, see if I can make something happen. Right? The old Ford wiggle test on steroids. And verifying the complaint. So some modules only act up when they're hot and cold. Some poor connections react to vibration. Do they live on a dirt road? Shorts may be related to harness position, which may change slightly according to driving conditions. How are the motor mounts? Module powers may experience higher voltage drop under certain conditions, especially when power is shared. And module grounds often open under electrical load, voltage drop. So this is kind of just some of the things. But keep in mind, if you can't verify it, you can't fix it. I mean, gee, it did it once and I can't verify it. Either you need to bring me a bag of money or take your car and wait till it actually acts up where I can duplicate it. Because otherwise we're just guessing. And there's nothing wrong with saying that. Look, I pay me for my cursory check. I did this, but it will not act up. So either you can leave the car with me for a couple weeks and I can charge you a bunch of money, or you can take the car and let me know when it starts happening regularly. And it'll cost you less money. And usually when you say that, the customers are really happy to take it and do your test driving for you.
Right.
I'm serious. I mean, I've known technicians and shop owners that are driving a customer's car for a week trying to fix an intermittent problem or duplicate an intermittent problem. It's like, why? When I'm done working, I want to go home. I don't want to drive the customer's car.
Yeah. Just push it away. Let the customer drive. Why you had to spend
Exactly.
time
And as long as you let them know, here's door number
on
one.
the thing intermittent problem?
Door number one is you can pay me a lot of money and I'll drive around with a lab scope and hopefully find something. I'm going to keep the car maybe weeks. Or you can go drive it, wait till it gets worse where it's easier for me to find. It's going to cost you way less money. Which would you like to do? Oh, I'll go drive the car. All of a sudden, the car that I can't drive it this way, they can't wait to drive it. It's amazing when you put a price tag on it, how people change their attitude. absolutely just
Oh
amazing
no.
when it happens. So scan tool communication and code checks. Can I communicate? Can I communicate with all the modules? What codes do I have? What PIDs are available? Is there network monitors like we saw with GM and Chrysler and Toyota? Is there network functional tests? So some scan tools actually have network functional tests in there that allow me to actually go in and do some functional tests on the network. Are there any pending codes? So maybe I have a pending code, not a mature code. Maybe I have pending codes that are 2-trip codes that actually are going to help me diagnose the code that turned the light on. All those are fair questions. And
What
then-
is network functional test? Well, what they do?
Well, it goes in, pulls the modules. It may look for voltage. It may, the different scan tools, I mean, different manufacturers put different functional tests into their scan tool that are network, quote unquote, functional tests.
Oh, so you're talking about a manufacturer scan tool.
Yeah, for the most part, manufacturers scan tool, although some
Oh.
tests are supported by aftermarket.
That means to complete the monitor itself?
What's that?
Does that mean to complete the monitor where it says ready at the monitor or no?
No, nothing to do with the monitors, just strictly the ability to go in and do some diagnostic testing. And a lot of times what it is instead of where we get do and I talk to everybody once, it's I'm gonna pull you and pull you and I'm gonna pull you. And as soon as you don't answer me, boom, we have a problem, Pablo. You
Oh,
don't
okay.
answer me, right? So, and that can be really helpful for intermittent or figuring out in what areas there's a problem because it's sitting there going, are you there? Are you there? Are you there? Are you there? And as soon as you fail to answer, boom, we're going to set a count. And so that can kind of so that can be really helpful for intermittent problems. Now, not all cars do it, obviously, not all scan tools do it, and so on. But those that do, that can be really helpful.
Okay.
So, since it is lunchtime, it's 12:04, 12:05. Let's take 30 minutes for lunch and we'll come back and talk about some codes and start getting into more of the heart of the system. So I'll see everyone back here at 12:35. Enjoy your lunch.
Thank you.
I know I will.
If you are interested in renewing your auto warranty now, please press 5 now, or press 9 to be removed from our list.
Đó đi, nó mày quay lại nè. Mày quay lại nè. Bò bò theo kêu nó mày quay lại nè. mày mua cà phê mày quay lại làm hả chị? Chơi, chịu không? Một cái sổ á, cho mấy hoa đi. Chị Dung ơi, em đi á. Tiếng á. Em đi mua cà phê em quay về chở mấy người đi bắt cho đi chùa ha.
help you too. Infusion and serious allergic reactions can happen during or after treatment. Entyvio may increase risk of infection, which can be serious.
So we feeling a little better after lunch?
What do you got back there, Brian? Palm trees and a lake?
It's
Swimming
actually
pool?
kind of a cool picture. It's actually the slab for my shop here at the house. When we were curing the concrete, we wetted it down and it was a beautiful day. And it kind of gives that, looks like a pool. So that's the view off my backyard, but it's actually a concrete
I see
slab.
it. I see it.
You can kind of see the stakes around the perimeter.
All right.
That's
You still doing exhaust work?
what's that?
You still bending up pipes, exhaust work?
I still can. I haven't in a while. I still can. I've got a bender here at the house and everything else. I just have no time.
Yeah, me neither. Me neither.
You know, I just drove my truck yesterday and realized the stupid timing, the water pump and the timing cover are seeping on it. And of course, seeping getting worse. And of course, mechanic's luck. I got really good stop leak here. It's like it's leaking at the gasket. I'll put a little stop leak in it and order up some parts. It's leaking worse today. It's like, you know, mechanic's luck. So it's like I got to pull the stupid timing cover off on my truck and reseal it and put a new water pump on it. And because I didn't have enough to do.
I know it. Yeah.
You know, the water pump doesn't have that many miles, but it is 10 years old. So, okay. But still, it's like, really? But always something. Wasn't planning on taking apart the front of the truck, but I guess I will be.
You'll be changing a whole lot more before you're done. Hardware or something. There'll be hose clamp. Oh man, I gotta go to the parts, you know. You know how it is at home. You don't have
A lot of that little stuff I have here, but
Oh, you do?
I'll have to order that up. But no, invariably it happens. You know, you always need something. But I got to put my Jeep back together and get it out of the shop before I can put my truck in to take it apart. So I guess, you know, got too many things in pieces. Or I just have
Oh
too many
man.
things, you know.
Hey Brian, I got a question. One long time ago, one guy came with the 2003 Chevy diesel. He went down south and someone stole his catalytic converter, and he went again down south and bought a used catalytic converter from another truck, same year and everything, and he put it on. What is that, like a fail or what? I didn't do the smog. I didn't want to do it. I told him, you know what, just take it somewhere else, man.
Yeah, that gets kind of gray a little bit. I've certainly failed vehicles for that.
Oh yeah, because it was the original one. He said he took it out from another diesel truck, same year and everything. But I could see
Yeah.
he welded it. He welded it. You could see it, and he told me the truth. But I didn't want to do this.
Yeah, you know, you can't get any diesel stuff aftermarket. And
Yeah.
if it's the factory stuff, and if it's, you know, because all that stuff is not welded, it's all bolt-in. So if they got the whole assembly and put it in, you know, just don't tell me anything and I'll smog it. But once you know, then you're like,
can't.
you know, don't tell the next guy.
Yeah.
Well, once you know, it's better off they've not have said anything,
Yeah.
you know.
But if someone cut it and welded something in the middle, that I'd fail because that's not factory. That's not how it should be. Something's modified something. Maybe the guy dropped it and made it hollow at that point. I don't know, but I certainly wouldn't be smogging it. You know?
Yeah, that's why I told him, you know what, take it somewhere else. I'm not gonna do it.
Yeah.
Some folks weld so good like the factory. If they had a year on it, you wouldn't hardly be able to. You probably would, but I mean, you wouldn't be able to tell anyways.
No, if I can't tell, hey, you got away with it. You know, I'm not the smog police. A certain amount of people are gonna get things by me. I'm okay with that. But when it's blatant, don't ask me to look the other way.
Yeah, of course.
And he had the police report and everything. I go, you know what, it's better just take it to the referee, man, see what they say. but I'm not gonna touch it, man. I'm not.
Yeah, I'd have
Good.
sent him to the referee. You did exactly what I'd have done.
Yeah, I go see what they say.
Yeah,
Now,
you
what's
don't
that-
Y'all
you don't
said
need
if
to
the referee passes it, he's got paperwork for next time showing the referee says it's okay.
Yeah.
you don't need to involve to the headed.
The important thing is don't take your 2003 diesel truck down south.
I don't go to Mexico for anything ever, period. It's just no reason to.
You know, I work next to the border, 10 minutes to the border. I see all kind of weird thing every day.
Yeah.
Yeah, I work at a Coronado Avenue, you know, like
Okay.
10 minutes to the border. All kind of weird thing happen.
That's a fact. Okay, so let's get back into our codes. I think I got almost everybody back. And there's Eduardo. Okay, and I already saw Tony. Okay, cool. So, U codes. Yeah, we know we're taught that U codes are network codes. What people don't realize is that B codes, P codes, and C codes may also be network codes, either directly, telling us there's a network problem, or more commonly, because there's a network problem. So, for example, maybe I don't get something when I'm supposed to have it. I'm missing information. Maybe a low voltage battery voltage code. Started the car, set a low battery voltage code. So these are all codes that are going to affect our network system. So that kind of goes into, is it missing a piece of traffic that should have come over the network? If so, what module should it have come from? So I might not have a U code, but I might have a network fault. On the other hand, I might have a U code and a P, B, or C code. And if I fix the P, B, or C, I've just fixed the network. So if I'm going to scan, I want to scan for what? All codes. So that's my diagnostic circuit check, or class 2 or GLAN DTC check, health check. Manufacturers have different names for that. Make sure we're looking at both generic and enhanced DTCs. We also have automated systems diagnostic tests where, the system will, we see this where air injection system or other systems will test themselves. We have some of those for network also. But automated systems tests do two things. First of all, they tell us if the fault is present now, which is helpful. The other thing is, since the fault is present now, the automated systems test is activating the system that I need to test. That means I can put a lab scope on it or other things on the system while I'm using the automated systems test to evaluate performance. So instead of driving it or trying to duplicate that and get lucky enough to have my lab scope on at the right time, I can use the automated systems test in conjunction with the lab scope to actually view the performance of the system that's not functioning properly in real time with the test. And obviously network tests also. I touched base on that briefly. So research, we talked about customer interview, but what about repair history? Repair information. Normal system operation. This is huge. Many times the customer complains about a car that's working normally because they don't know how the car works. It didn't work like the last one, right? My last car never did this. Technical service bulletins and other bulletins. So we can get bulletins for, like, for example, transmissions, because it's fresh in my mind. ATRA, Automotive Transmission Rebuilder Association, has their own transmission bulletins. So if I have a transmission problem and I'm not finding anything on my favorite Identiguess, and I didn't see anything in Some Data or Mitchell, maybe I want to go to the ATRA website and do a search there, because guess what? That's free. So, don't limit yourself to just factory TSBs. Wiring diagrams. Some of us have access to online or phone-in technical help. Now, that's what they do at the dealerships, right? You get to a certain point, get on the tech line, start a thing.
You might as well not even be a mechanic. You just
But that's, well, you know, the dealers do that. I shouldn't say the dealers, the manufacturers do that because they don't want to train technicians. They only want to train them up to a point. After that, call somebody because it's cheaper to have someone to call than it is to train all the technicians.
But is it really, Brian?
It is for the dealer. I mean, not for the dealer, it is for the manufacturer. Because, you know, if they send someone to factory school, that's room and board, that's, you know, I mean, there's all these other things involved. Plus, that person may leave. So that's why they have the hotline or the tech department for a lot of this stuff, because they'd rather, you know, train 10 people than train 1,000 people. And so I don't think it's good if you're a technician because I think it limits your skills, which if you limit your skills, you limit your marketability, you limit what kind of jobs you can get. You know, you might as well be flipping burgers at McDonald's now. You know, it really limits your value. So I don't think it's good for the technicians. I think the technicians are better off being trained. Especially there's some manufacturers that don't pay any time while you sit on hold for 40 minutes with TechLine. So that's
What?
Fine.
That's crazy. Oh, that's insane. You might as well be a shade tree dismantler / you know, oil change. I mean,
Yep.
there's no way you can. Wow. I don't
No,
know why
but-
people go for this. I don't know why people cut themselves short with the confidence and go for this.
Right.
It's-
And unfortunately, what happens a lot of times, 'cause I have a lot of dealer techs in my classes, and there's some real sharp guys that work for the dealers. But yet, you know, I'll have other guys in the dealership, they'll talk to TechLine. TechLine will tell them to put a part on the car. It fixes the car. They have no idea why it fixed the car. So they went through the process. The customer got a fixed car, but the technician has no idea why it works now or why
That's
that car was changed.
That's insane. I mean,
Yeah,
you
well,
know?
me working aftermarket like you, Daniel, I want to know how, and I figure out stuff myself. And most of the time, I mean, there's things that you're never going to figure out. But I mean, I've burned on a lot of stuff, and I might take it as a pride. I like learning. I really enjoy that, and that's probably why I never worked for a dealership.
Well, it's like, man, if I mess up on the air brakes, Class A, or even
Right.
on some of these tractors, but you know, we were down on the Mexican border. It's a 75% decline, and it's 80,000 pound vehicle. And once you roll over, the transmission shifts 1, 2, 3. I mean, the retarder's got to work. I mean, I have to know why I fixed it, how I fixed it, so that when I drive off, okay, that guy's gonna make it home to his family. You know.
Exactly.
It's like that on the freeway too. You know, the brakes are working for grandma or the single mom or whatnot. She can slam on the brakes in LA. You know, I know I fixed the ABS, this, that, and the other. You know, I know that that's a good repair. I mean,
Yeah, but how many people do brake jobs that have no idea? They can't solve a brake job if it pulls when they're done, or can't solve it if the pedal goes to the floor.
yeah, I get it.
They're lost in the cars at the shop for 3 days because the pedal goes to the floor because we put in brake pads and they can't diagnose their way out of a paper bag.
Right. I get it. I understand. Yeah.
Now, there's a big difference between changing parts and understanding how the parts work. So here's a first pass wrap up case study. This vehicle came with a complaint that the driver's door locks and windows aren't operative. A scan of all modules for codes revealed that the driver's door module, J386, was not communicating with the network. So this is a 2007 Audi A3. And so we go into the possible causes. Certainly a bad module, power ground to the module. I could just start ripping the door panel off and doing some testing, but let's grab a little more research first. So here, looking at the various JPIDs, J stands for modules. Some modules from all three are up and communicating. So I have modules from each of the three networks that are talking. So it can't be a network fault, right? At least it can't be past a certain point. So I don't have a shorted network. The lack of driver's door function is probably directly related to the network code. But on the other hand, it's not necessarily a network fault. So here we go in. This capture shows all the selected modules are online and communicating with a 1 next to them. Remember, we're all at 1s and 0s, except for the driver's door module. So the driver's door module is the only module that has a problem. Now we look at the wiring schematic and we can see the driver's door module. We've got communication lines that come in from the outside. There's about 6 wires. We got our network lines, our powers, 2 powers, and grounds. So we got what, about 6 wires heading through the door? Does it make sense to look at where the door opens and closes before we rip the panel off? So here we opened it, we pulled it back a little bit, and what do we find? Broken wires. So I have no doubt that everyone would have fixed this car.
Yeah, I see it a couple times happen,
Yeah.
right there.
Yeah, Volkswagen wires are too big and don't bend. But the point is that with spending, looking at a couple extra screens, we proved what it's not. And that's the point of the case study. It's not that it's hard, and it's not that we couldn't have fixed it a different way. It's that we didn't have to take the door panel off. We didn't get into pinpoint testing. We asked some questions based on the code, ruled out what couldn't be wrong. Now we know the problem has to be in the wiring going to the module or the module itself. Now it's where do you want to look? Where the wiring most likely go bad? Where the door opens and closes or inside the door? So our second pass, visual inspection. You think, wait a minute, electrical, what's a visual inspection by me? I think everyone knows the value of visual inspection, especially when you have someone else in the shop that looked at it, they don't see anything wrong, and you walk right over and go, what's this? You didn't see this? Right? That's what experience buys us, is that visual inspection. Check the diagnostic link connector, termination, circuit and resistance tests, module resets, and lab scope tests. So if you notice, we kind of go down here. So would I check the DLC? Well, it depends on what problem I'm having. If I can't talk to anybody, yes. If I can't talk to just one module, then no. So each of these has a different value. Am I going to check termination resistance every time? No, because if I can talk on the network, but there's only one module I can't talk to, why would I check termination resistance? That's stupid. Of course, it's not the problem. I can talk to everybody else. So depending on the fault you have is going to determine which of the second pass tests you do. Remember, just like level 1, level 2 diagnostics, your level 1 is that information gathering hypothesis. A lot of times we fix it with that. Your level 2 is pinpoint. Here with this, our first pass is that information gathering initial test. Our second pass is going to depend on what did we find in the first pass? What kind of problem am I trying to solve? So do I need to do voltage tests? I'll show you how we may actually use a test light on a network system. Signal generators and module power ground wake up tests. So again, am I going to do all these tests on every car? Of course not. Circuit isolation for shorts, grounds, or out of communication. Circuit overlay for opens, which I talked about earlier, or module bypass for opens and shorts. What if I have a daisy chained module and I think the module is causing the problem? Well, how about unplugging the module and run a jumper wire from the network in to the network out? Does everything work now? It's simple when I say it, but how many of you thought about it? Gee, I think it's a bad module. I don't have anything coming out. I got something going in and got power, but gee, I don't know. Well, take a jumper wire. Jumper your in signal to your out signal. Does everything upstream work now? If it does, guess what? It's definitely the module.
Can we do that?
Yeah.
Wow. I thought in and out they send different voltage or frequency.
Not if we're daisy chained, where I'm taking the signal going into this module and coming back out to the next module. The signal in and the signal out are basically the same signal. So I can disconnect the module and then place the module, put a jumper wire between those two, see if everyone else talks.
Wow. Okay.
That's a pretty easy, low-cost tool, isn't it?
Yeah.
It beats
Sure.
guessing on a module. So here's one scenario. It starts, runs, everything works, no communication. So a DLC Bob or breakout box may help your connection. It gives you access to circuit tests. I'll show you what that looks like coming up. This may also be caused by a scan tool fault, so checking with another brand might be a good test. For diagnostic only protocols like ISO 9141, networks that only talk to the scan tool, a network fault won't affect module operation, so it must be on the list. For gateway systems, you might simply have all the other networks communicating, but failure to connect to them through the gateway. For intermodule networks that also connect to the DLC, a network fault is extremely unlikely. No start, no communication. Guess what? It's not a scan tool or DLC fault. Hard network faults like shorts. Opens are also possible as long as the open isolates all the modules. Maybe I have a dead important module, like a master module or something is dead, so or gateway where we're not working right. Could have a termination resistance fault. So start isolating modules. What's my topography? Do I have a parallel system where I can get to a junction where I can just unplug everything and then plug them in one at a time? Is it daisy chained where, hey, let's get to the first module and disconnect everything after that, see if I can talk to it? So again, it's gonna depend on access and that, but start isolating stuff because I can't talk to anybody. So my problem has to be between the scan tool and the first module as far as that. I need to isolate that. Now the problem, let me rephrase, the short could be after that, but I need to at least get to a module. So it depends on how the network's configured. If I'm going to all modules at the same time, start disconnecting things to figure out where the leg is. Right? Because if I'm shorted and I want to find the short, what do? Create opens. Communication with some modules. So I could have an entire sub network that's not working, or I could have partial. So if a partial network. So if a group of modules aren't communicating and they represent every module on a particular network, then opens or shorts are very likely, including faulty modules. However, if a group of modules aren't communicating and they represent some but not all of the modules on a particular network, then an open in the network circuit is very likely. Are you following the logic there? If I'm shorted, it's going to affect the entire network that communicates on the same language, should have the same voltage. If I'm open, it's going to affect the modules after the open. Lack of communication with one module. I could have a bad module. Try that module on a different network. So we have modules that talk on more than one network. Check activity on the network at the module. Check powers, grounds, and wake ups. Try a hard reset of the module. So obviously one module that doesn't talk is much easier than a group of modules, potentially, just on the limited number of options. Like I said, most of the time, if I can't talk to a network, it's a DLC problem. I could probably count on one hand the ones I've had that have been something else shutting the whole network down. Maybe two hands. So here is a BMW, multiple code case study. It's a 2013 650i. Lots of weird stuff. Doors open themselves, convertible top operation erratic, windows are stuck. Scan tool is used to retrieve all codes. And again, the list was far too long to even start. So
send to the dealer.
What do you do? Well, if I have a lot of codes and don't have anywhere to start, I need to choose a path. And the simplest path is let's clear all the codes and see who comes back. Right? Because I don't know how many people have been working on this thing. I don't know what's going on, how many. Let me document everything, dump it, clear it. And so once we do that and we get a whole bunch of these codes back again, it made sense to look at what the modules that are setting the codes have in common. And in this case, look at the wiring schematic and component locator. We found that they're all in the trunk. And BMW decides on a 650i, you don't get a spare tire. Instead, we're going to use the space to put modules in there. So a little visual inspection, I think we may have found a problem. So BMW has a formed area in the spare tire, but no spare tire, rather it's used for millions of modules. As this part of the trunk contains no drain holes. So while throwing away the spare tire to make the gadgets, room for the gadgets seem like a good idea, the moisture in the truck is going to get very expensive. So they made a strip. Guess what? What are the odds this is the only BMW that's filled up the trunk with water? Okay.
Yeah, they happen to the Mercedes-Benz too on the SUV.
Yeah.
On the rear same module, is the water get in there.
So does it make sense to check for TSB at this point to see if there's a fix or a solution? And in this case, there was a TSB, and it describes how to use a sealant on the trunk hinge bolts. So the water is actually not coming through the gasket, but through the hinge bolts of the trunk.
How can you miss that? You always put, come on. Jesus.
So what you do? Put a silicone on a pinch hole.
Basically, I'm sure it's BMW sealant 023 458 356, but basically,
Hey, a copper crush washer would work. You know, like aviation will work, Hermetex. I mean,
yeah, there is options.
Hey, you can put pipe tape on the threads of the bolt. I mean, come on.
But what do you think would have happened had the shop put a bunch of connectors and cleaned stuff up and modules, whatever it took to fix it, and then the car came back in 6 months with water and the same problem again?
Yeah.
So, I mean, there's a point where it's worth checking the TSBs even after you found the problem with the car.
Oh, okay. Makes sense.
So that case study really had two things. One is check TSBs even after you found the problem, especially with something like that, this got to be happening to all of them. Is there a better fix? Updated harness, whatever. The other is don't forget the visual inspection. We fix a lot of cars by looking at them. Let's be honest. I don't care how many tools you have in your toolbox. Your eyes are one of your most valuable tools.
Right.
Don't forget to use them. Okay, so DLC drag check. So the truth is a huge number of no communication faults with no symptoms are bad DLC. And this is because of terminal spread. And this happens for a couple of reasons. One is technicians incorrectly testing things. The other is a lot of cheap code readers do not make their pins to specifications. First clues that this tool's pins are not to specifications is pins 4 and 5 should be longer than all the other pins.
Just drive down there. I'll call them for you.
If they're not, then the connector is not made to specifications. Because BMW going through the OBD2 process, BMW is the one that got in, but pins 4 and 5, which are ground connection pins, are supposed to be the longest pins of the DLC. They're supposed to engage first and disengage last. And if you look closely at your connector on your scan tool, you'll see those two pins are just slightly longer. So if they didn't get the pin length right, what do you think the odds are they got the pin thickness right? And that is why sometimes that cheap code reader hooks up and talks to a car and that expensive scan tool doesn't, because the cheap code reader pins are not the specification, they're slightly thicker. So if I'm going to drag check the terminals, I need a pin that's the correct thickness and see if I have good grip when I slide it in and out of each of these pins. So there's a lot of tools on the market that we can get drag check tools. You can see here, you have the J tool, which is a factory Kentmore tool. We see here on the right, one from a kit that we see below that has multiple different sizes of connectors, and you match up the right size.
Thank you, buddy.
So this is the OBD2 breakout box I was talking about. So there's two connectors. And if you look at the connectors here at the top, there we go. One goes onto the DLC, the other one your scan tool plugs into. You have lights on here. So I got a red power light for power, 2 green lights for ground. And then I have yellow lights here that tell me if I have communication, because they're going to be flickering when things are talking. And you can actually watch a scan tool in generic mode or the smog machine start off, and usually they start here, they start off, go through the protocols, and they always check CAN last, then they'll come back and do it over again. Usually they'll do it 2 or 3 times going through the different protocols before it gives up. And you can actually watch it. So that's how I can tell, is the scan tool trying to talk? So if I plug this in and say I can't talk to a car and it's a CAN vehicle, and this light, yellow light, just is on all the time or off all the time. And I watch the scan tool go through and hit all the other ones and blink, 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 and nothing there. Odds are pretty good we got a shorted network. That's why we can't blink. On the other hand, if I see that flashing, that tells me what? My scan tool is trying to communicate. So if I can't communicate with the car, I probably have an open or a bad gateway module. Now it's time to test the DLC by going to the back side of the DLC. And I usually do this with a scope. I'll throw one channel on the back side of the DLC and the other channel on the banana plug on the breakout box. Are both my signals the same? If they're not, guess what? I just found my problem. It's the DLC. I also had one car. It was a Mercedes. It was really kind of interesting. I could talk to the computer, but the computer couldn't talk back. And we actually saw that on the lab scope pattern. So going to the computer, they were both the same. But coming back on this side of the DLC from the computer, I saw a signal, but nothing was getting to the scan tool because the computer obviously had less amplitude, less force in the signal than the scan tool did. So that was interesting. And that was on a early 2000s Mercedes. But again, I found the weird problem because what I do, it's not shorted, must be open. Throw a lab scope on both sides of the DLC and let's watch my signals. It should be the same both sides. If not, it's a DLC problem. And so this is pretty quick. I use this when my smog machine doesn't want to talk to figure out, is it a bad car or my smog machine's acting up. I use it all the time. You can see this is long enough. You just put it up on the seat next to you. That's a lot easier to hook a scope up to or do tests with or anything else. And I'll show you another trick we use with this in a little bit.
You came to the conclusion to use this because you can't communicate with a scan tool. This wasn't actually a network code or U code or.
Right.
It's not going to know. It doesn't care if you can conduct through that connector or not, correct?
Right. But we started diagnosing the car because the check engine light was on. So the check engine light was on. We were trying to get codes. That's why we were trying to communicate. And then we get codes. It's like, okay, I got a check engine light on and I can't get to talk to it with a scan tool. It's one of my students' cars down at the college. And so we have this, I've had the college buy these. So I was able to walk through and do that and walk through the process with the students and showed how we fixed this overwhelming, the sky is falling. I can't talk to my car and the check engine light's on to, you got a couple bad pins in a DLC. He ended up going to the junkyard, got it used DLC, and we moved some pins around and done.
Yeah.
So, but no, this has just been a real handy tool for a lot of stuff. So termination resistance. If you have a two-wire network where the traffic isn't supposed to be the same, then there's no termination resistance. For example, an SCI or RX or TX networks have 2 wires, but the traffic on each side is different. It's like a freeway where I got north and south lanes. I don't need termination resistance because they're completely independent networks from each other. The north and south lanes are. They're isolated. You know, if I'm on the freeway, other than all the looky-loos, traffic on the northbound lane shouldn't affect me driving south. If it wasn't for all those people that want to stop and look, it wouldn't. Unlike if we're sharing something in common where we're connected. So these networks are not connected through termination resistors, don't need to be twisted for shielding.
It's a nice Jeep.
So termination resistance testing. If I want to test termination resistors using an ohm meter, which is how most manufacturers' procedure is, I need to wait 10, 20 minutes with the key out minimum for the modules to go to sleep. Keep in mind, some cars take an hour for the modules to go to sleep. So, you know, I could also use a lab scope to check network activity. And I don't need to wait 10, 20 minutes or an hour. And I can still figure out if I got a bad terminating resistor. Do it the correct way. Start pulling fuses or the battery cables. So many manufacturers, GM, for example, actually want you to disconnect the battery to test the terminating resistance. Well, that's great. I don't need to wait so long. But we were just talking about how bad things happen when you disconnect the battery, and sometimes weird things happen. As well as I lose all the memories out of whatever I might have had there to test. So we definitely have options. If I'm going to test termination resistance, CAN network normally has 220 ohm terminating resistors, 220 ohm resistors in parallel, give us an effective resistance of 60 ohms. So that's what I should see at the DLC. And so as I test between pin 6 and 14, I should see somewhere around 60 ohms. It's not going to be exactly 60. So 61.4 is just fine. So don't die on that. It's off a little bit. On the other hand, if I have 20 ohms resistance, that's a major problem. If I have 120 ohms resistance, that's a major problem. If I want to know if fixing the resistance is going to solve the problem, I can add resistance, can I? So if I have, say, 80 ohms resistance, couldn't I add more resistance in parallel and that would drop my resistance down to 60? Right? Because the more resistors we add in parallel, the more the resistance of the circuit divides. If I have too little resistance, I could add a resistance to just one leg of the network, and wouldn't that increase my parallel resistance?
Yeah.
So again, going back to the breakout box, I could get one of those decay boxes that has the dials or the little flippers and have my meter and start clicking switches or turning dials till I hit the magic 60 ohms, and now see if it talks. If it does, I just proved I have a terminating resistance problem. Now, not only do I know why I can't communicate, I know that when I fix the terminating resistance, I'll fix the car.
Now, what's the name of that box you're talking?
The decay box is normally what they call a decayed box.
It's like for when you use for like fuel gauges and shit.
Yeah.
Decay, huh?
Yeah, it's like decayed or decayed box. My English is so bad, I'm probably pronouncing it wrong, but the ones you see now are a yellow box about this big that has a whole lot of slide switches on it for ones, tens, hundreds, thousands.
X-Tech. Does that sound familiar? X-Tech?
Yeah, kind of. I think they make them. They're yellow.
They're yellow and they got three like banana plugs at the top or something.
Yeah.
Black, white in the middle, and red.
Yeah, they got a bunch of names on them, and they all seem to look the same. So I think the same factory is making all of them.
Well, here, can you look at that?
Yep, that's exactly what they look like. They make them for capacitance also. If you think you have a noise problem, you can actually throw capacitance on a circuit.
Wow.
I have an old school one that has dials.
That's probably better than the switches. Easier.
Yeah, mine's an old Blue Point one from many years ago for testing.
It's probably that guy.
No, mine looks a little different than that. But I have 4 dials, but same idea. I got a ones, a tens, a hundreds, a thousands. It's old Blue Point one. Closer. Mine looks different, but same idea.
Yeah.
And what I use, if I need to get an exact amount, I use my own meter to measure how much resistance I have in the box. If I'm just trying to change resistance, I'm going to turn the dial till I get the number.
Right.
And I'll measure it when I'm done. So we have
Ryan.
an 07 Highlander, and this was earlier you saw this. This was in our
Ryan.
interview. What's that?
Question.
Yeah.
Usually when you have a short in the page before, when you have a short, how many ohms around?
If I have a short, I should be down close to 0 ohms.
Oh, okay.
Because
Under
the
the
short
60.
is a lack of load in a circuit.
Oh, okay. All right. Thank you.
You bet. And Samuel, you and your brother went down to ECC, didn't you, when you guys went through school?
Yeah.
You did, right?
Yeah.
Yeah, because that's where I'm teaching now. So that's what I thought.
Oh, yeah.
Small world. So this is a Highlander with no HVAC connections message. Air conditioning was stuck on one setting. Other multi-display functions were dead and or error messages. And these problems all started after the radio was changed to an aftermarket unit. So the initial inspection, we removed the multi-display, removed the radio, found 2-wire connector dangling, not connected to anything. Oh, and it's a twisted pair. What do you think that's for? Maybe a network? So fortunately, the customer had the old radio. So when we looked at the old radio, we saw where it plugged in at. And what we did is we hooked up an ohm meter and saw there's a resistor there of 68 ohms. Sounds like a terminating resistor. So the customers already bought their new fancy super duper radio they really wanted, but they kind of like the air conditioning not to be on full cold all the time. So we need to come up with another solution. How about putting a 68 ohm resistor in? Hey, now everything works.
Huh.
Gotta love radio shops. You know, the guy came back and said, hey, ever since you put my radio in, it does this. And they probably said, yeah, but it's nothing we did.
Radio shops are the biggest morons. Idiots.
Well, how much can they really get paid when you look at how little they charge to put a radio in and how long it takes?
But yeah, you'll see Bentleys in there and Mercedes, AMGs, and this and that. And oh my God.
So that resistor was inside the module?
There was a resistor inside the module. We went and bought a resistor and plugged it in.
Yeah. Could have been 67,
Oh, is this
70.
Yeah, probably.
This case, the resistor inside the radio, right? So we modified
it was originally inside the radio. And this is interesting because this is simple. This was just a terminating resistor. We can cheat that. Some of the new radios are actually the master module for the system or a gateway module for the system. So I don't know what these aftermarket radio companies are going to do with some of these new cars. How do you take out a master gateway module and put in an aftermarket radio?
I did one on a Suburban or a Yukon. They're actually selling the modules, and you have to program them through your Bluetooth or whatever. I did one. It was kind of a pain in the ass, but it came out nice. It
Really?
kept all the factory buttons. It kept OnStar. It kept everything. Everything worked. Of course, I did a real nice job with it. I didn't use everything was Deutsch connectors and shit. But
Scotch locked, got
it. Yeah, $50 a connection. So
right,
it came out really nice. So yeah, it works. It worked. Everything works. Never had trouble with it. Yeah.
But is that radio is a gateway?
On
module?
some, not on this car, no, but on some cars, the new ones, it's actually a gateway module.
Yeah, that radio was a gateway to the volume buttons, to the airbag, to the everything on the steering wheel. Yeah.
So after Mac is parts, people figured out a way to
Well, they're
modify.
gonna have to, or they're out of business.
Yeah, yeah,
What-
okay.
So if it goes to the airbag model too, doesn't it have to pass some sort of approvals?
I don't know. Amazon sells the shit.
Yeah.
Customer
Yeah,
order.
you know what I mean?
It was
Because
for
what if
my-
you got an accident and didn't deploy or
Yeah,
something
it's
happened?
It was
Yeah,
the wife.
go to China and sue them.
It was
Yeah.
the wife. It was the wife of my Snap-on guy
Huh?
out in Lakeside. And he said, she's going to Arizona. Can you come out and da 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 blah blah. So I drove out there on a Sunday. And
No, I wouldn't dare to try it. You know, I know even though it works, but you know
it works. Been running for 2 years. I mean, if you
I know, but
know,
you don't
can
involve
wire,
to
you can
the,
wire.
like accident and the airbag not deploy. You know, it's just
Yeah.
that's the
no,
gateway.
it's- well, and you can buy a lot of stuff just like the HID kits that aren't legal. Some work okay, some don't. But they're so it's amazing what you can buy on Amazon.
Yeah. Well, I didn't buy it. They bought it, so it's on
Yeah.
them, man.
But
Yeah.
that being said, I mean, I was working on a friend of mine's 59 Chevy truck, and its stupid alternator is bad. He had a chrome alternator on it. Brand new 110 amp, one wire chrome alternator, $75 plus tax delivered on Amazon. 1 year warranty. I mean,
Yeah. Well,
plugged it in, things charging great.
this one's on the road for about 2 years now.
Yeah.
So, well, with the airbag, it's set up with redundancy and stuff. If there's any issues, it's gonna throw an airbag light.
Exactly.
never
Probably
not-
will.
I've
No,
never
as
not.
long as the airbag light's not on, it's going to deploy.
I've never not seen any. I mean, any little issues. That airbag light comes on for whatever. I've
Right.
never not seen. So
I agree.
Yeah.
So circuit resistance tests. So if I'm looking for a short, I can short network to network. What I mean is my high can is shorted to my low can. And that's already really covered with our termination resistance test, because if I'm shorted, I'm not going to have enough resistance. I'll be well under the 60 ohms. Network to ground, network to power, or excessive resistance in the circuit itself. And so the best tool to do all this stuff is a lab scope, because I can do it all at once. Why would I take things apart, do this test? Now I got to do this test. I got to turn and do this test. Or I can do some lab scope tests and do everything all at once. For circuit resistance, I need to test at 2 points on the circuit, but my lab scope's still going to be way more accurate than using an ohm meter. So here's a 2000 Chevy View. Complaint of no radio operation, and the ABS, TCS, and wrench lamps were on. The vehicle ran fine. So no other details were offered. And our first capture shows I have no communication with the EBCM or radio not shown. So according to the diagnostic steps, we attempted communication with other modules, and the section capture shows the history code for the BCM. Capture also is going to show us a 2108 as a current code. Oops, there we go. And so 2 unrelated modules don't talk to the scan tool or other modules. Best test, check powers and grounds on those modules. So sure enough, the radio and EBCM fuses were blown. Replacement fuses didn't blow. Now the customer explains that they jump started the car.
backwards.
Well, it's because it's always cheaper not to tell us what they did. So again, network codes, network fault, blown fuses. Well, I know everyone here knows how to test a fuse. That means everyone can fix this car.
Back to basics.
Trick is not to go down the rabbit hole unnecessarily.
So the first thing is just
So scope. If I'm looking at my setup on my scope, time, voltage, triggers. For network, we don't want to use a trigger. I want to use twice the expected voltage. And I want to use more time than I need. So I'm probably going to start with 50 or 100 milliseconds because I can always come in. Voltage, I'm going to start with, 12 volts, 20 volts, and then bring the voltage down. The idea is to get something on the screen and then adjust the picture so I can see what details I want to see. If I use a trigger and my trigger is not where the voltage is, I will never see anything on the scope. So you do not want to use a trigger when you're setting up to do a network. And that's one of the things that really frustrates people when they first use a lab scope if they're used to a graphing multimeter. A graphing multimeter doesn't use a trigger. A scope has a trigger. A lot of times they default to the on position. Turn the stupid trigger off. Let it see everything in whatever voltage scale or scale you're using. So that way you get everything that's there. And now I can adjust to make it look how I want it to look. But if I put a trigger, it only paints a picture on the screen when the voltage crosses the trigger voltage. So if it never crosses the trigger voltage, you're going to be looking at a blank screen forever. So for example, I have a CAN vehicle, 2.5 volts, and I'm looking at the high side that's supposed to go to 3.5 volts. So I set my trigger at 3 volts. Perfect, right in the middle. And I never get a pattern. Well, it's because the CAN high is shorted to 12 volts. Or CAN high isn't triggering, and it's 2.5 volts all the time. It's never crossing that 3 volts. Therefore, I will never see anything on the scope. Or
So you're saying
0 volts. You'll never see anything.
So you're saying default no triggers?
Default no trigger. And then if you want to move the pattern over to make it pretty or do a measurement, then use the trigger to hold the pattern where you want it. But your initial setup, no trigger, especially on networks, because I might be completely out of range. Yeah, it's a 0 to 5 volt scale, 2.5 volt bias. So I'm going to choose 5 volts for my scope. Well, that sounds great, but what if I'm shorted to 7 volts? I'm out of range. I'll never see anything.
Yeah, sometimes maybe you short to the 12 volt or 14 volt. Yeah.
So you want to go enough voltage that anything that's there, so you're going to see anywhere from 0 to your system voltage. Your trigger, you don't want one. And your time, you're going to go a little slower time. You're not going to have detail because you can always bring in the time. But what you don't want is something going past the screen so fast you can't see. So you're talking, 100 milliseconds, something like that, or 50 milliseconds per division. Put a little time up there. You're not going to have good detail. You're going to have to probably zoom in, depending on the speed of the signal you're looking at. But at least you can get something on the screen. Then you can zoom in to see detail.
Just put 1 second.
But if you're already zoomed in, you blink, you just missed something. Remember, you're running without a trigger. So it's not going to hold the pattern. It's going to show whatever's happening live. So you want to be out far enough that you can see what's going on. Then you can use a trigger or zoom in or do whatever you need to do if you want to see detail. Different scopes work differently. Something like a Pico or an ATS. I could take a big capture, then go in and zoom in on other parts. If I'm looking at the Snap-on, I can only zoom out. So I need to get something on the screen. Then I can really zoom in to get detail, freeze it, zoom out to get context. So using a Snap-on scope is very different than using a Pico or an ATS scope, or even on a telescope, which operates more like the ATS and Pico does. And I'm seeing more and more shops with the telescope.
So most likely when you test this, you test at the DLC, you're looking for they talking or?
I'm going to show you what we're looking for when we get to that, because I will show you not only what you're looking for at the DLC, but if it doesn't look right, what it means.
Right.
Great question. Just let me get to the answer.
Okay.
So here's an example of why we do 2-point waveform comparison. So I can't talk to the PCM in this example. So I'm going to use my breakout box of the DLC and I see a pattern. Well, that pattern should be the same everywhere in the network. Here I back probe the DLC, the PCM, and I only get a little bit of pattern because all I can hear is the PCM talking to itself. I don't have the rest of the network traffic. So therefore I have to have an open between the PCM and the junction connector. So here's an example of why I use, and this is, I mean, yeah, can I go to the junction connector and ohm out to each module to see if it's open? I could do that, but a lab scope tells me instantly what's going on. In this picture, we have 2 lab scopes. In reality, we use 1 lab scope, 2 channels. So here I'm going to use 4 channels on a CAN system. So I'm on a Toyota, and we had a communication issue. And if you look, I have the blue and green are on the good part of my network, and my yellow and white are at the side that's having a problem. So if we start at the bottom and look at the white, there's no negative pulses on those short pulses. So over here, there's no negative pulses. That's because these pulses are coming from other modules. This is coming from the module on the other side of the open on the CAN negative leg. Since only the positive is going through the open, negative can't go through the open, we do not have an inverted pattern for that signal on the CAN. So therefore CAN positive and CAN negative are both going the same way. They both see the CAN positive from the bad leg, but just for that message. The other messages are normal.
So what really gives the clue there is that on the yellow is the peak just before the large pattern.
Uh-huh.
In the white, it's missing.
It is missing there.
That's our telltale sign.
And again, like I said, we're not getting any of those peaks on the,
Okay.
on the pattern at all. Exactly.
Okay. Okay.
So we're not getting traffic from anybody else. We're just hearing ourselves talk. But if I'm at the DLC, I'm going to see what we see on the blue and the green, which is, wait a minute, why does my network not mirror sometimes, but mirrors all the other times?
Hmm.
Yeah.
Well, that's because the module that's sending that circuit has an open on the negative leg, so we're only getting its positive story.
So you only see it from that module.
Yeah. Remember, we're connected through the terminating resistor. So if I don't have an offsetting signal, we're just going to go right through that resistor and we're going to mirror whatever's there.
That's kind of cool.
Because we're not going to drop the voltage because there's no load. There's nothing to keep it separate.
What did we show when the module go bad?
Well, it depends. Did the module go bad and just not talk?
Yeah,
A flat line.
all of them.
No, just from that module. So my network communication would look normal, but I wouldn't be able to talk to that module. So I back probe the module, look at the communication. Communication looks normal. I have power and ground to the module. Well, if I got power and ground and no communication, it's a bad module.
So you're going in your scan tool, interrogating each module and keeping note of which modules you're interrogating, and you're watching the waveform.
No, these are just them trying to talk to each other. I'm not initiating anything right now.
Oh, okay.
What if it's like the other one with external power? I mean, I guess that would be the exception where you have to check that external power to wake up the modules.
Right. But see, it's woken up because it's talking.
Oh, I get it.
You see what I'm saying? This is
Yeah,
strictly a bad connection.
I get it.
And I think this is way more accurate than using an ohm meter because you know 100%. You were led here by the scope pattern. You know what module you couldn't talk to with a scan tool. The scope pattern shows I have an open on the negative loop. And now let's go down and pin it out here at the connector. And hey, we found out what pin's bad. Here's another example. This capture shows GM class 2 network activity, single wire network, 0 to 7 volt network. activity of two different splice packs on the same vehicle. Do they look the same?
No.
No. So I'm using two channels of the same scope. And here I'm at the two splice packs. These should be the same. They're not. Therefore, I have to have what? A problem with the wire connecting the two,
Yeah.
or the connection here, or the connection here. But if I'm back probed here and here at the connector, that eliminates the connector. That means what? This wire has excessive resistance in it.
We could just simulate, put a new wire there.
What's that?
You could simulate and just put a new wire there and see what.
Yep. Absolutely, you can. Put another wire. Does everything work? This work now? Hey, I found the problem. I proved it. Yeah, don't be afraid to do that. Here's another example. This is one that had 400 ohms resistance in the network. And so we see we don't have quite the amplitude. We're used to the 90-10 rule for sensors, right? If it's above 90% or below 10%, it sets a code. For network communication, remember we're switching ones and zeros. So the 0 is usually somewhere around 20% and the 1 is somewhere around 80%. So it's not uncommon to see different heights on the toggling based on the for message structure, but the toggle points are normally about that 80-20, 80% and 20% of the voltage of the communication range. So it doesn't need to go all the way to the top and it doesn't need to go to the bottom. As a matter of fact, you'll see it normally only goes all the way to its bias voltage when it takes a breath. Just like we do when we're talking. We talk, take a breath, talk some more. Modules are the same way. When it takes that breath, that's when it goes to the bias voltage.
And what is bias voltage here?
And this one here is 0 volts.
How much?
This one's at 0 and gets pulled high to talk.
Oh, okay.
So you can see the little pauses where it's flat, got a little flat line. I got another slide I usually talk about this, but you got a little flat line here, flat line over here, flat line here. That's the separation between the messages on this
Oh, okay.
particular vehicle. I got a capture coming up that'll do a better job of explaining it. But for now, let's take 10. So I'll see everybody back at 148.
Whew. More than halfway.
Time flies. Okay. Everyone back in here.
Hey.
All right. So next slide I have is looking at traffic between the gateway and the scan tool, which is our diag CAN-C, and the communication between the gateway and the regular CAN network. This happens to be on a Chrysler. So these are both speaking the same language. They're both CAN-C, but we see the activity is not the same. So here we have initiated communication on diag CAN-C with the scan tool, which carries through. But now what? There's communication going on in the network we're not seeing, and then we're going to get back the information we asked for on the scan tool. So if we have different networks, even though these are both the same language, they're going through a gateway, the traffic's going to be different on either side of the gateway. Now, one of the issues that happens is, well, the gateway goes bad and now I can't talk to anybody. Well, in the case of Chrysler and some other manufacturers, the language on the diagnostic network to the scan tool is the same as the language on the other side of the gateway. So in the case of Chrysler, what we can do is use our breakout box and disconnect the breakout box from the DLC, but leave it connected to the scan tool. And then use jumpers, you see here in the green and the yellow, to go into a module on the CAN-C network. So the other side of the gateway or the gateway itself might be difficult to get to. So could I go to a different module on that network that's easier to get to? So we backprobed the fuel control module because it was easier to get to than the TIPM, which was the gateway module. Same network.
What do? You literally push piercing probes right down in?
Yep. We backprobe the two network lines and jump them right to 6 and 14 on the breakout box, hook the scan tool to the breakout box, and bada bing, bada boom. All of a sudden, if I can talk to everybody on that network, guess what? The gateway module is bad or doesn't have power, one of the two.
So then you're billing out to find out if it has power.
R&R gateway module and verify powers and grounds once you dig it out.
All right, easy enough.
Yeah. No. Or you do the, here's how much labor is involved, and I'll let you know what part I find once I get to the gateway module. It's all about accessibility. How hard is it to get to?
Now, when you install your modules, do they already come programmed, or you got to call in another guy to?
Depends on the module.
Yeah.
But yeah, I just call someone else in to do it. I mean, I have a J box, I have that stuff, I have some factory scan tools. I'm going to spend more time loading the software and my stuff and everything else to do the flash. If something goes wrong, it's all on me. You know, we paid $125 to have someone come out and flash it. I can go do a brake job or something else in the same time. And if the smoke comes out, guess what? It's on him. Yeah, I used to do a lot of flashing. I got to the point where it's just, I mean, for the shop, it's a difference of about 20, 30 bucks. By the time my boss pays for the subscription, the boss pays me to do it. It's within 20 bucks or 30 bucks of paying someone to come out and do it. What's the point? It's better for both of us if I do something else. Plus, things do happen when you're programming. I know that from the programming I've done. And sometimes it's a 2-hour figure out what the heck happened to get everything working right. Well, I got to figure the guy who's doing it every day has already had that happen a few times. So he already knows, where I'm starting from scratch. Again, wasting more of my time. So I'm actually a big proponent of have the mobile programming guys come out and do it. Unless you work at a shop that only does, Toyotas, or we only do BMW, Mercedes, or we only do, Nissan products or whatever, where you're only doing a couple product lines, why would you program it yourself?
I call it a mobile program
Yeah. I think it makes sense.
because those guys do every day. They know what's up.
Right. And how much money are you making doing something else while he's programming? More the difference in money you'd make doing it yourself.
Double
Exactly.
minimum.
So some things, it's not about how do you do it, or can I do it, or can I get the tool to do it? It doesn't make sense for me to do it. But I thought this was a cool workaround. Again, if you think it's a problem, go around it. Checking for shorts. If I use a high quality test light, like an LED test light, will only light if the network's shorted. So here I'm going from power to my network. And then I can go from ground to my network. If the test light lights up, we have a problem. Why? I got 220 ohm resistors. We shouldn't be lighting up the test light.
You on the end of that test light, it's shaped and formed to slip into that.
Yeah, what it is, it's actually a banana plug, and then the banana plug plugs into any of these adapters.
And the test light is a banana plug. It comes.
Yeah.
Oh fuck! I need one of those.
Yeah, well, you can see the part number right here in the picture.
Yeah, I'm doing it. I'm getting on it. Hold on.
Well,
I need
it's in your book too, Dan.
Okay.
Okay.
I need that.
Yeah, it's pretty slick. So
Well,
here's-
I just throw a light on a mill or a lathe and turn it, and then
Yeah.
get the right.
So signal generators. So I have one of these, not this model. I have an old PRI SST tool. This is Kentmore's, but allows you to put frequency or duty cycle or something onto a circuit. Well, if you think about it, isn't your scan tool a signal generator when it tries to talk to a network?
Yeah.
There you go. Some new scopes have a signal generator built into them, so you can actually turn that on. Several of the ATS scopes have that.
Really?
And again, because it's the quickest way to figure out whether you're dealing with an open or a short circuit. Because if you put a signal on with a signal generator and you still have a flat line, your circuit's shorted. If you get a signal, you're fighting an open.
So Snap-on sells one, but they've been back ordered for a long time. It's only $75.
Really?
Yeah.
That's cheap.
That is cheap.
Yeah, but they've been back ordered for like 6 months.
Yeah.
I didn't think Snap-on had
Sure.
anything that was $75, with the exception if you needed a replacement plaque for your toolbox.
I really think Snap-on's getting outdated behind this electrical. I mean, there's so many used Snap-on sockets and ratchets out there that they're really falling behind.
Yeah. I got a lot of used Snap-on sockets and ratchets, but I think I'll keep them for a while.
Collectible.
I've been turning to Proto. It's the stock number is EESX306A. It's a generator diagnostic waveform.
Okay, I think I know. I think I've seen that. It's real small,
Right.
almost like
Yeah.
a little circuit board. Yep.
Yeah, but it's bitching. I've been trying to get one, but it really would it helps me in the tractor world because there's no books, no nothing. There's no
Right.
one to even know where to turn to. Well, I look at the sensor, maybe it's an IAT or maybe it's a duty cycle solenoid or something, and I just put it on. Okay, does the light go out?
Yeah.
And it's kind of like plugging and playing in sensors. Well, I have another known good used sensor here. Let me plug it in and see what it does. Right.
No, that makes sense. So here is, one of the mistakes people make when they check for power and ground in a module is they unplug the connector and then see if voltage is present. Well, guess what? If it's unplugged, all that is open circuit voltage potential. So, in this example here,
I see a lot of people doing that.
looking for voltage and ground. Make sure, you actually have it when the module's
Yeah,
trying to
yeah.
work.
I saw a lot of people, my coworker unplug it out. Oh, we had the power. No, man, we don't test like this.
No, if you're going to unplug it to see if there's power, at least put a light bulb between the power and ground, see if it can light a light bulb up or something.
Yeah.
So testing without testing, check available scan tool, power and ground PIDs, check wiring diagrams carefully. So this is kind of a continuation of what things can we prove by looking at PIDs, looking at the circuits before we actually start digging the tools out and taking the car apart. And so the book kind of gets into that a little bit, looking for voltage drop issues, looking for some of these other things that might be affected. If I have 5 modules that don't work and they all use the same ground, maybe my network code is a ground problem.
Visual inspection.
Yeah. No HVAC communication. You mentioned this earlier, and I've mentioned it a couple times. Use an overlay. Hey, I can't talk to the HVAC module. I think there's an issue. Let me grab another wire and go between my splice pack and the HVAC. Hey, I can talk to HVAC now. I must have a bad wire. I haven't used an ohm meter. I haven't. And I think I've proved that has to be the problem. I mean, you got to get to the HVAC module to do an ohm meter test anyways. You might as well just run a jumper and see if you can talk to it. And this is an easy single wire network. If I have a jumper, I can also, and I have a shorted network or erratic communication, I can run a jumper one at a time and see if I can talk to each module till I hit the module I can't talk to. And that's the leg that's shorting the network.
And you mentioned earlier that you could do that on the other end at the module, right?
Yeah, if they're daisy chained, right?
Daisy chain.
Right.
So again, a lot of my diagnostic options come down to how they build the network. Is it a parallel network like this, or is it a series daisy chained, or how they build it is going to decide which cool tricks I can use.
Visually, would you be able to tell the difference between daisy chain, like if you were under the dash? Are there any telltales? No, not at all. Don't even try to go there.
No, I mean, I'm not saying you never could look at a module and figure it out, but no, go to wiring.
Right. Okay.
Just go to the wiring diagram, right?
Yep.
Yeah.
So here is a case study on an 08 Jeep Liberty. Many dash lights come on, and we lost communication with the sunroof module. So this is a major catastrophe. So the complaint was the lights and a lot of communication codes, but most of them were stored, meaning history. The only active code was for the HVAC module losing communication with the sunroof module. Naturally, if the sunroof module is offline, then it can't report any codes itself. A topography check proved that it was unresponsive. Now, unresponsive doesn't mean bad, and it doesn't explain the many dash lights, right? Because if all I have is a bad sunroof module, why does my dash look like a Christmas tree? And why do I have codes everywhere else in history? So many of the codes are stored in the ABS module, and many in the PCM codes indicate loss of communication with the ABS system or missing data from the ABS. So here's our topography. And what we did is similar to what we did before, is start over. Let's clear everything and see what comes back. In this case, there's so many codes, we decided to record them all, clear them, then operate the vehicle in various systems to see what comes back. After codes were cleared and the vehicle was test driven, some lamps started,
I'll take care of
including
Keep your
the
ass alone, man. Rest a little bit.
The capture shows the YTEC topography and indicates the ABS module is unresponsive. It also indicates that the TIPM, WCM, FDCM, HVAC, and sunroof modules all have codes. Now, wait a minute. I couldn't talk to sunroof before, but ABS had codes in history, and now I can't talk to the ABS, but sunroof talks. So this is a great example of, what do we chase? Well, we chase the rabbit that's moving. In this case, ABS is the current problem. We got codes in other modules indicating that it's not happy with ABS. And time to take a look at the system. Do I have a TIPM issue? Do I have an ABS? But right now I can't even talk to ABS. And ABS module is fairly easy to get to. So doesn't it make sense to go there to test? It's what I currently can't talk to. It has good accessibility. And I just cleared everything, and this is what came back first. So what it is, we hooked the lab scope up to the ABS module, and this is what my network communication looks like. So we took a bigger picture, which is in the small box here, and then we zoomed in this little rectangle, and that's what we see on the screen. So tell me what you guys think of this pattern. What are your observations?
The height, the amplitude.
Amplitude. Okay, so I should be at 2.5 volts, which would be right here, and go up to 3.5. And it looks like my bias voltage might be a little off.
Mhm.
And on this side of my red, 2.5 is going to be somewhere around here. Bias voltage is about the right spot. I've definitely got, I got a lot of even when I don't have anything going on, I got a lot of spikes, and these spikes,
Bad ground.
what, the same
like-
direction, aren't they? I mean, these are bigger than this, but these are all going the same direction.
Mhm.
Even though I do have an inverted pattern.
Yeah,
here.
but they're inverted there.
But I got all these spikes here in the middle when I should be pretty much a flat line. Also, my bias voltage doesn't look flat. It looks like it's kind of like a roller coaster, doesn't it?
Mhm.
Yeah.
Kind of wavy.
Arced. It's arced.
Exactly. That's not normal. That's not a good pattern. So erratic communication faults and a horrible looking CAN pattern leads me to have a couple possible options. I could have a weird terminating resistance problem.
Are you saying that these smaller spikes in between should be a straight flat line?
It'd be a straight flat line.
Because it's always going to be 2.5 volts.
Yep.
So there should be no.
I should have communication, a flat line communication.
So maybe these are signals bouncing around, coming back.
Right. And if I look at my voltage ranges, things are a little high, not super high, but they are definitely a little higher than I'd like.
I think
And
could it be connected to like another signal somehow, or getting interference from another signal?
definitely getting interference. What we see with this roller coaster of the bias voltage is normally a bad ground.
Okay, yeah, that's it.
Okay. So if you have a roller coastering or elevated VREF for your 2.5 volts, first thing is suspect a ground. Now, the issue is, gee, where does the network ground from? Well, every module, right? So what happens is if I have a module with a bad ground, now when it does things, it's going to influence that bias voltage because it has a bad ground.
Can we just
So-
add a ground simulate on top?
Why? The problem is I can't add a ground to the two because I ground the 2.5 volt bias.
Mm.
So it has to be a module with a bad ground. Now, in this case, I have a module that's not talking, right?
ABS.
And we have a network that's a star type network, meaning that we start from a center tree and we're not star, but we're a parallel network, right? Where everything is going off on its own. So couldn't I just disconnect ABS module and the network should still function fine, right? I don't need the ABS module for the network to work. We all
Yeah, it's already communicating, not communicating.
Yeah, not for communicating. I mean, people are going to be pissed off I can't talk to it, but we already got that. So
Yeah.
I should be able to unplug the ABS module and still have network communication with everybody else, right?
And then watch the pattern.
And watch the pattern. How's the pattern look now? Different?
Yeah.
Okay. Even if I didn't know good and bad yet, I definitely would know different. And what's more, now the only codes I'm getting are, hey, we can't talk to ABS. So this happens to be a bad ABS ground. Am I diagnosed yet? No, because I don't know if it's a bad internal ground in the module or a bad external ground where the module gets its ground from. So you know what? Let's test the ground. We don't do that with an open circuit, do we? So let's put a load on it. So using the load substitution box that we developed in our last class from the electrical class from UT 59, we got 4 light bulbs in there. That's 10 amps.
You would put 10 amps on those wires?
Heck yeah. What size fuse do you have for the module? If it's a 10 amp fuse, I certainly would put 10 amps of load.
Okay.
I mean, if you're a coward, put 5 amps.
That's what I 7.5.
There you go. 3 light bulbs, 7.5. In this case, it's ABS. Remember, ABS modules usually have a pretty big fuse because what? They also control the ABS pump.
Right.
And
Yeah, that
relays.
is true.
So they're usually a pretty robust module.
So where did you tie in?
We disconnected the module. That's the connector in the picture. And we front probed the power and ground with the load substitution box.
I guess maybe in this case, it would be good to check the alternator output. I mean, I guess these are basics, but output of the alternator and state of the battery.
Yeah.
You know,
So
to
wait a
begin with.
minute. You're grounded to your light bulbs off the battery, and then you.
No, not off the battery, off the connector.
I only see one probe in the connector.
Right. That's the ground probe. The power is hooked up to the battery.
Oh, okay. All right.
So, but we're going to check power and ground right at the connector. You know what? If I can fire up 10 amps and have bright light bulbs, we should be able to power up a module.
So then you're switching at the connector from ground to power then,
Yeah.
and switching your terminal at the battery.
Yeah. Or you
You can
could
put-
use 2 jumpers right at the connector if you wanted. But here they isolated one at a time.
Right. Okay. Got it.
So why don't you check at power and ground when you hook up the ABS control module back, and you make sure the power and ground good, and we determine the ABS module is bad.
Well, because but I can certainly back probe it and do that. But if I have a bad ground inside the ABS module, I'm not going to be loading the circuit correctly.
Yeah, you're testing the circuit like this.
Yeah, because so the advantage of this is that I'm just isolated the circuit, the power and the ground. I got great power and ground at the module. There is no doubt.
Yeah.
Now,
I got good
all you have to
network.
look at is a module.
When the module's not there, it has to be a bad module.
Yeah.
Now, what about this wake up deal you were talking about? How can you rule that out?
We see external wake up circuits on some of the higher speed networks. Right now, no one's using that on normal high speed CAN.
Okay.
So is this
So
something
again,
that's going to
schematic-
be new or?
Yeah, schematic would show you that, but right now, no one's doing
Okay.
that on high speed CAN.
So again, you're gonna research schematic before you pull this. Okay.
Sure, because I got to know which wires to start hooking light bulbs up to.
Yeah,
Again,
cool.
we're sitting in the air conditioned office, pulling PIDs, pulling
Yeah.
schematics, pulling.
Using that information system, the boss sure doesn't pay for itself at only $180 a month.
Right. All right. I know. That's the culture, man. And they're wondering why, shit doesn't work.
You know, I think that a couple $100 a month for that information system is one of the cheapest things you can buy as a shop when you look at how many hours it buys you of productive time. Okay, so big picture. Our network fault to likely cause overview, our first pass diagnostic test, choosing the best second pass test based on possible causes, second pass test diagnostic process, and then some sample diagnostic pass. So as we go through this, it's kind of a recap of what we've been doing. And it's all about the process. So again, no scan tool communication, no symptoms. Here we go. Try all modules, generic and enhanced. Scan tool connector pin separate is most likely cause. Does it have a gateway is a secondary question. Module network problem, and then open or short circuit. So it kind of goes down from most likely to least likely problems, things to eliminate to come up with that. So here we have a 2013 Jeep Grand Cherokee fault. The backup camera is inoperative, so the person cannot operate the vehicle. And we are highly dependent on the backup camera.
What?
A park assist system message is displayed. We have faults in 4 modules. Instrument cluster codes are loss of communication with the park assist control module and loss of communication with the compass module. There are other codes, but the U0159 explains both the original complaints. So doing some digging in that direction makes sense because we find all kinds of things wrong with the car, but would it account for the customer's complaint? So here, first pass research, we found fuse 34 circuits from the TIPM. The fuse powers the park assist module as well as a number of other modules, components related to the rear camera and rear sensors. Fuse 34 is blown. So it's not a diagnosis, but it's a clue. Fuse 34 was open and was replaced. And the vehicle was checked again. And instead of 18 modules, we now have 20 modules. We also had a little bit of smoke out of the front headlamp for a minute. Not quite a minute, a few seconds. But all the modules are online. We now have Parktronics and auto headlamp leveling. Wait a minute, didn't I say we had some smoke out of the right front?
Yeah.
So with the fuse blown, there's no way to talk to the headlight system. So, and we still have a U code. So now, freeze frame. The fault was detected at 135,289 miles, most recent 135,319. So this is a current fault. We went to use some bidirectional controls on the headlight system. And we found that the value never changed from the 65535. This means that what? We're not moving. This is a default value. So obviously smoke coming out of the module, lack of communication, and the fact that we couldn't change the adjustment on the headlights means that the backup camera didn't work because it has a bad right front headlight module. Good news is that module is only $950 and comes with a brand new headlight. So $950 for the assembly and labor.
So the module built in the headlight.
Yep. So the backup camera didn't work because the right front headlight's bad. This was not a network problem per se. I mean, we had some blown fuses causing modules to go offline, but it's the network that caused the problem. And if I'm going to get to the root cause and actually fix the customer's car and not have it show up tomorrow with the same problem with the fuse blown, these were all important steps. That, remember I talked about scanning all modules, all codes, both on an initial diagnosis and after we do any repairs, to see if more modules come online. So you can imagine the bar complaint now. This shop ripped me off. They sold me a headlight to fix my backup camera.
I would believe that if you told me that.
Yeah.
I would lose the bet on that one.
Yeah. And seriously, I mean, if they went to a shop that really didn't understand how vehicles work today, you could see where a shop could wind a customer up. Well, that's ridiculous. That can't cause that. Boy, they ripped you off. What did they, you know, I mean, and we run into that, unfortunately.
No, the thing is you call the customer to explain how the network set up, and if they understand, authorize the work. So
right. And
Yeah,
it's really important that we do take that time to try to educate our customers, isn't it?
sometimes you have to sell the
You
job.
have to.
Yeah.
Absolutely. So here I have an 07 F-150 with no speedometer operation. I have a code 500 for the VSS and a code 1502 for the VSS and a code U 2023 in the instrument cluster module. So again, going with where should I start? How old are these cars codes? It makes sense to get my data clear it, go drive the car, because we're gonna have to drive the car anyways to test for a VSS problem, and let's see if we can duplicate it. So we cleared it because, I mean, we could have a network fault preventing the VSS data, right? If I have an open network or network problem. So we cleared it and we went for a test drive and see which one comes back first. And what came back first is, and only code that came back is a U2023. So we drove it to 30 miles an hour. My speedometer still didn't work, but only the 2023 code's set. However, when we went to the flow chart for the U2023, it specifically says fix all other codes first. So even though my 500 didn't reset, since my speedometer is not working and it says fix other codes first, it makes sense to verify the vehicle speed signal at this point. And verify that the instrument cluster can work. So the first thing we did is we connected to the instrument cluster. We used the bidirectional control in the scan tool that you see below, and we told the speedometer to move at different speeds. So we verified a couple of things by doing this. I verified the speedometer can work. I verified communication with the instrument cluster, so we know that part of the network's good. And we verified that the instrument cluster responds on that network and is able to work correctly. That means there's no reason to put a lab scope on here.
Sure.
Right? Because we just proved it works. Why would I lab scope it?
Yep.
Right? So now, where does the VSS come from? Well, we went into documentation. It said it was on the output shaft of the transmission or in the transfer case on a four-wheel drive. So we went down to the transmission, went to the output speed sensor, and we verified it's there. We graphed the data, and we can see my output speed sensor PID moves, but my vehicle speed sensor PID doesn't move. So according to the flow charts for P500 and 1502, they both refer to the VSS or OSS in the transfer case or the output speed sensor. So we have no VSS signal. Now, is it possible that our documentation's bad? So this is I got to regroup. The flow chart is no help because we tested the sensor that's supposed to be my VSS, and I see a PID for it. It's moving. So there's no VSS. The flowchart reference to the OSS indicates the OSS is the source of the VSS. The OSS works, but is not being converted to a VSS value. In the module, because we're on the PCM, we can see both things here. The speedometer itself works when controlled by the scan tool. The CAN and UBP, which is a secondary network, are both functional because the scan tool can communicate with them, command instrument cluster functions, and receive PCM data. Other possible causes. Is it possible that we're getting the VSS signal from the ABS sensors? And documentation is like 2 years late? We've all seen that, haven't you? Where they just cut and paste, cut and paste, cut and paste in Mitchell, all that, or whatever. And they missed the memo that something changed. So it does make sense to look at our ABS sensors. So what we found is that all 4 ABS sensors work perfect. So now we're back to being confused. The VSS works, all the ABS works, the instrument cluster works, the speedometer in the instrument cluster works, but there's no vehicle speed signal through the network telling it to work.
Could be bad BCM.
What's that?
It could be bad BCM.
BCM, but we're not necessarily using the BCM.
Well, what is sending this signal once it picks it up from the wheel speed sensors? That's the guy that's
okay. All right. So every possible source of the VSS signal is fine. The speedometer is capable of seeing the command and all network functional tests. So what's left, right? And you kind of hit on it. How does the signal get from the wheel speed sensors to the network? Well, that's the ABS module, isn't it?
Yes.
And that's the guy.
So is it possible the ABS module's bad? Yeah.
Well, it show
How to
for
prove it gets a little harder, right? Because I don't have any ABS codes. It's working, and I don't speak CAN. I can recognize when it's being spoken, but I don't understand the
Well,
language. Is
this
there
is-
another possibility short of replacing the module?
This is
And
perfect for a signal generator.
right. But the module already sees the signal generator coming in, but I have no VSS on the network.
On the output.
Exactly, on the output, which is a network output, so I can't just use a signal generator there.
Right.
But the other thing is, does the ABS module know that it's supposed to do that?
Well, you need documentation. I mean, how are we gonna know?
So is it programmed correctly? In this case, the wrong VIN was in the ABS module.
So you got this from another shop that did an ABS module.
Yep. And again, the documentation is probably 100% correct for some cars. So they got a used ABS module for a different VIN that probably did use the speed sensor on the transmission or differential. Or transfer case. So this module was never told, hey, I'm supposed to share that information. So it was reflashed using the as-built programming for the correct VIN. And now the speedometer works. So this wasn't really a network fault, even though we got a network code. Many times we get network codes, not because the network's down, but because the information that's supposed to be transmitted on the network is not present. So when you get a network code, is it a circuit code, open short, or is it an information code? I'm supposed to get a vehicle speed sensor signal and no one sent it to me. Therefore, it's a network code time. There must be something wrong with the network. I didn't get my information. So, and the thing that sucks is the codes don't tell you which of those it is sometimes. So we do see where sometimes a network code is nothing wrong with the network. It's a lack of information. Other times a network code is a hard network fault.
So the ABS is receiving the signal, but he's not talking back to the network to say, hey, this is how fast I'm going.
Right. He didn't get told that was his job to take out the trash today.
And that's what programming the VIN does.
Yep.
Okay.
so they put in the ABS control module, but they're not flashing it.
Right. They put a used one in from a junkyard. Car runs, lights off, ship it. But the speedo doesn't work. Now, to be fair, maybe the speedo wasn't working with the module they took out because it went bad, right? So the shop's like, was it working before? Is it working after? Do you want to diagnose? No, who knows? I mean, it's easy to Monday morning quarterback and drive the bus over the shop, but you don't know what was corresponded there. But I did think this was good because by treating this as a network fault, again, using logic, we never hooked a lab scope up here.
Right.
We used what? Deductive reasoning and a scan tool.
But you have to look on the wiring diagram to see that the speed sensor go to ABS control module first, and then they network to the PCM, right?
Yeah. So the output speed sensor went to the PCM, but the PCM sees it, but no vehicle speed. So that means, is it in charge of converting that or someone else? Again, probably programming. If it had a different VIN, it would probably do that, right? Because there's always options, 2-wheel drive, 4-wheel drive, and so on. In this case, we looked at the ABS, all the ABS sensors work, but it's not sending the signal out. So doing a little bit of research into programming, figure out, hey, does everybody have what they're supposed to have? That's kind of one of the advantages of having VINs burned into some of these modules.
That's tough to catch.
Yeah. I mean, this is one of those, it's a simple solution. It's a week-long problem. So control area network, what we've all been waiting for. So we're talking about low speed CAN, medium and high speed CAN, some manufacturer specific naming variations, some manufacturer specific voltage ranges, and some other non DLC CAN networks that break all the DLC rules. So CAN overview, we have non-DLC CAN. That means a CAN network that is not connected to the diagnostic link connector. We've had CAN networks on vehicles in this country going back to 1992. I can have multiple networks at the DLC, and I can have more than one CAN network at the DLC. Like as I mentioned before, CANs are open architecture or open platform, so it gets interpreted differently. And then we have network termination that although we use two 220 ohm terminating resistors as a rule of thumb, there are exceptions. So just because I don't get the resistance I want doesn't mean there's a problem. And that's why I like using a lab scope, because if my lab scope pattern's good, who cares about measuring termination resistance? If it's bad, then I can look at that scope pattern, and with the tools I'm going to give you here in this last section, you can figure out, is this shorted high, shorted low, open terminating, shorting terminating, and so on. And I'm going to get that information off the lab scope with one hookup instead of running a bunch of different tests. And it takes into account for how each system works. I don't need to spend a half hour trying to look up information.
And then that goes back to where you said you got to wait for the car to go to sleep and then tie in and check resistance.
Yep, or disconnect the battery, right. Now, terminating resistors are in some interesting spots. Sometimes they're in modules. Sometimes they're just a little cap on the wiring harness. Sometimes they look like a fuse in the fuse box. You don't suppose the guy sat over the weekend on YouTube checking his fuses might have pulled out the 120 ohm resistor, do you? Also, some manufacturers use non-permanent termination resistors. The terminating resistors are only connected to the network with the key on. So I can't even do an ohms test. Another reason why a lab scope test is better, because if I had a communication problem and I had, infinite resistance, I think, oh man, I got an open circuit. Well, no, I just have terminating resistors that aren't connected, because that's normal. So I'm either going to make a wrong decision or spend a whole bunch of time trying to find information about the terminating resistors for the system I'm working on, both of which can be a waste of time. So basic rules often broken. CAN A is the same as low speed CAN, about 10 kilobits. CAN B, medium speed CAN, about 250 kilobits. CAN C, high speed CAN, 250 to 1,000 kilobits. CAN D is going to be FlexRay, or most is normally how it's the names you're going to hear for those networks, 1 to 400 megabits per second. So you're getting into, it's what, 200, 300 megabits per second. You're getting into good home internet at that point. Terminology in a blender example. So am I talking about B CAN or CAN B? So some manufacturers call a system B CAN for body CAN, has nothing to do with the topography or the protocol. They're just calling it a B CAN because it works on the body. Or Mercedes calls D CAN diagnostic CAN, D CAN. Well, it's a CAN C system, but they call it D CAN. Am I talking C CAN or CAN C? CAN high and low. Am I talking speed or polarity of the signal? Many other confusing variations. So just like most of the things we do in automotive, we try to make it confusing deliberately, it seems like sometimes.
What can we take as a default position as when it's supposed to talk? Is it when it's being pulled up?
Depends on the network.
Well, just like, how you had like in your mass airflow and stuff, just some default.
No, there is. And unfortunately, with network systems and these protocols, there's not a one size fits all. Some are low and talk high. Some are high and talk low. Some are in the middle and talk low or talk high. Some are mirrored. Some aren't. Some have a bias voltage. Some don't have a bias voltage. Some use a 0 to 5 volts and they use a 2.5 volt bias voltage, which all of our 6 and 14 can do. There's other can systems that use a 5-volt bias voltage on the high and a 0-volt bias voltage on the low, or vice versa. I mean, it is really the Wild West.
So oscilloscope cuts all that shit out.
It does.
Okay.
Because we know that if I have a bias voltage, it should be a straight line. It shouldn't be doing this.
Right.
I mean, so there's certain, even if I don't know what it is, I know what's not right. And that's really kind of one of the beauties of an oscilloscope. It's not that I know what it should be, but if I look at a few things, I'm going to recognize things that it shouldn't be.
Definitely. Okay.
And how do we do that? By looking at systems that don't necessarily have a problem, instead of letting the scope collect dust until we have something we really needed, and then pull it out, try to figure out how to use it for the first time, and then try to make a good decision. So ATG standards for our network terms in this book, we use low speed CAN, 1-wire low speed network. So this is our GLAN for GM. Medium speed CAN is going to be a 2-wire medium speed CAN network, and high speed CAN is a 2-wire high speed CAN network. So that is, because there's so much terminology out there and so many contradictions, I wanted to put things into, when we're talking about it for the next remainder of the class, so next 55 slides or whatever, I wanted to make sure that we're understanding the same things as I bring these terms. So on that note, let's take 10, and I'll see everyone back at 2:45.
Hold on, just before, could you
Yeah.
put amp clamp? Could you throw an amp clamp around these and get anything?
You get something, but you're going to just know that there's current flow.
That's okay, but it's not useful for anything.
Not useful that I've seen. Or
All we want to deal with is voltage. All right. Okay.
good question, but haven't been able to do it yet. All right, we ready?
Yeah.
Yeah.
I'm ready for 4:30. That's what I'm ready for.
Yeah. Well, the last part of this tends to go quicker than the first part. So I will tell you that. Because case studies always tie up a lot of slides and go quicker. So low speed CAN circuit faults, because low speed CAN is a single wire network, circuit faults are much simpler to understand. Shorts to ground hold the circuit low, preventing modules from pulling the voltage high to talk. Likewise, shorts to voltage hold the circuit high, which also prevents toggling depending on the voltage of the short. Opens only prevent communication with modules beyond the open. If I look at high speed and medium speed CAN circuit faults, if I have an open circuit, I could have an open terminating resistor or an actual open circuit. And the effects of short circuits are shorts and bias voltage will change. And we'll hit a short circuit summary. So there is a lot of information on pages 310 to 312 on this. You might want to earmark for if you're diagnosing one of these back in the shop. Like normal, I'm not going to read the book to you. So terminating resistor testing, most dual wire cans is 60 ohms. There are some medium speed can variations such as Chrysler non 2.5 volt bias networks, Hyundai and Kia don't use 2.5 volt bias, and VW Audi don't use 2.0 bias on their medium speed can network for their comfort and convenience system. Be aware that DLC termination may have different resistance between the DLC and the gateway. So again, this is our rule of thumb. Some network classes you've taken probably say everybody has this and you're always gonna have 60 ohms. You should know by now there is no always in the auto business. There are some good rule of thumbs. There are some normally, but it's important to understand that also some of these systems only have terminating resistance when the system's powered up, and we can't test terminating resistance with an ohm meter when it's powered up. We can see here in testing a terminating resistor that's isolated. It's 121.6 ohms. So the 120 ohms is kind of a rounding error. Kind of Daniel, you asked me when we had the one with 60 ohms. Would that have been, would 65 have been okay or 70 been okay? Yeah, probably would have been. Because they do all have that tolerance. And we see that in this table here. So 60 ohms is my correct resistance. Doesn't prove there's no fault, just that the fault isn't related to resistance. If I'm below 50 ohms, unless there's 3 resistors, low end resistance indicates a short between the can lines. This may be in a module, but is almost always a circuit fault. If I get 40 ohms, tested as below 50, unless there's 3 terminating resistors, because 60 divided by 120 divided by 3 is 40. And that's a normal number. If I have 70 to 110 ohms, that's going to be a circuit connection resistance or module resistance fault. If I have exactly 120, and you know what I mean by exactly 121, whatever, 118, that's an open terminating resistor, or an open in the can circuit going to the leg with the terminating resistor. Over 130 ohm steady circuit connection or module resistance. If it's erratic or intermittent, that network is still powered and communicating when you're trying to get your resistance spec. Disconnect the battery. If it's infinite, you have an open can circuit, or you have non-permanent resistors, or both resistors are open. What are the odds? So again, not as good the scope, but this is in here. It gives you kind of some basic rules, or at least questions to ask. Terminating resistance, as I said before, here's the decay box. Not sure if resistance is the problem. Use the decay box. Add in series to increase resistance. Add in parallel to decrease resistance. Back to Ohm's law. If I add more resistors in parallel, I increase current flow through the circuit, lower the effective resistance. If I add resistance in the series part of the circuit, then I increase circuit resistance.
You can add that resistance into the DLC?
Yeah, so if I want to add it in parallel, I use my breakout box and connect this up to pin 6 and 14, start flipping switches till I get to 60 ohms on my meter. If I was low, then I would hook it up in series on pin 6 or pin 14 between it and the scan tool, try to communicate and see what happens, because I would increase my resistance, because I'd only be adding it to one leg.
Okay.
So adding is harder, takes more jumpers. Lowering is easy because it's in parallel and you're just hooking up and flipping switches. Since you don't know how much you need, it's easier to flip switches or turn dials than try to do math, because your math's not going to be right. There's too many unknowns. There's obviously a problem. How big is the problem? I don't know. Flip some switches till you get the number you want. I can use a DVOM, which will give me some information. So for example, here I can see on my CAN positive, it goes between 2.2 and 3.5 volts. And my CAN negative goes between 2.7 and 1.4. Does that mean that it's not shorted to 0 and not shorted to system voltage or not shorted to 5 volts? Yes. Does that mean it's communicating properly? No.
Can I do the old light bulb trick to see if it's shorted to ground and power up?
Yep. Like I said, so the DVOM gives me some information. I'm toggling in the right voltage range. I don't have a dead network, right? I don't have a shorted network. But what's wrong or how good is the communication? Who knows? Doing tests like this, if this is your only choice, isn't all bad, but you need to know what it tells you and what it doesn't tell you. It doesn't tell me the network's good. It just tells me it's able to talk on both CAN high and CAN low, and it's talking in the normal voltage range. When you think about it, the Chrysler with the bad ABS module was talking in the normal voltage range too, wasn't it?
Yeah.
So again, doesn't tell me it's good. It just tells me it's not shorted to ground, not shorted to power. It's able to move the voltage on both of these. So I know some of what's not wrong, but I don't know it's good. And that's the mistake people make when they use a tool like this. They say, I use a DVOM and it's good because it shifted these voltages. No, it moved because it shifted these voltages. So here is lab scope testing. This is low speed CAN. So this is a 0 to 5 volt circuit. And if you notice, we got 12 volts here to start with. Well, on this circuit, that's the wake up signal. So it wakes it up with 12 volts and it talks at 5. When it's not talking, it's at 0. So even though this is our low speed CAN, we can see here that it doesn't go all the way to 5 volts and it doesn't go all the way to 0 volts when it's talking. That's our 80-20 rule we were talking about. But when it stops talking, it goes down to its rest voltage, 0 volts. So if we're trying to send a message and there's 0 volts on the line, we must be shorted, right? So that's where that short to ground code would come from. Gee.
That'd be a flat line on 0?
Yeah, that's what we have right there. And I'm pointing out the 2 flat lines on 0.
It stays that way though when we're shorted.
Exactly. So if the computer's trying to talk and it sees that, hey, we're at 0 volts all the time, we know we're shorted because we talk between 0.5 volt and 4.5 volts.
Now something like this
all the time. Hello, we're shorted to power.
Can we hook up our scanner, our $10,000 scanner, and have some issue right here where it smokes our scanner?
No.
In the DLC or something, the scanner connector, it has a resistor or a
no, but there's 2 resistors in the circuit in parallel. So I've shorted them. We've shorted them to power and shorted them to ground and hooked up a scan tool, and we've had 0 issues.
Okay.
So I think the scan tool manufacturers put some pretty good protection in there after the problem with the VWs on the KWP 2000, where they're putting battery voltage on the communication line, and the smog machines were having a problem, and they had to upgrade the smog machines. And I think scan tool manufacturers learned from that lesson.
They were plugging in smoking the scanner.
Yep.
So it's almost non-amperage.
Yeah. Like I said, these systems are surprisingly resilient and protected. So here is normal low-speed CAN activity. I got 140 milliseconds of activity and 17 messages. This is low speed. So when we think of low speed, it's not like we're crawling along here. Do I really need something faster than this to, I don't know, request air conditioning?
That's like 2 milliseconds or something. 3.34 to 3.48. Is that what I'm?
140 milliseconds.
That's pretty fast, dude.
Yeah, that's what I'm saying. And this is our low speed. So that's what I'm saying. For a customer, this is instantaneous. And this is our cheap system. So here we can see length and timing variations, voltage variations. This is normal. Not all messages are going to be the same length. Not all of the switches are going to hit all the way down at the same level, high or low. That's normal. They just need to get past the switch point. So here's a wiring example of our low speed CAN system. It goes to pin 1 and then goes over to a splice pack. So our low speed CAN for GM, which is what this one is a DLC network. Not all low speed CAN systems are connected to the DLC. GM's is. Some of them have to go through a gateway and then get transmitted to high speed CAN, and then we can talk to with the scan tool. But this looks very similar in physical structure to a class 2 network that GM used for years. So from a wiring standpoint, it's basically the same. The protocol is different, the language is different, but the wiring, the physical structure is going to be the same. Just different modules. So here's an isolated low speed CAN where we have a gateway module and it communicates through the high speed CAN. So on this vehicle, the low speed CAN is not connected to the DLC. Only high speed CAN is, and we're using a gateway module. So from a scan tool, this is normally seamless. We don't see that change. So on a scan tool, unless we have to actually start diagnosing a problem, we don't see any difference here on the scan tool. We don't know where it's getting the information. It's only when we have a problem that these things start to become important. So let's look at some lab scope testing. So presets may lead to false failures. In other words, scan tool lab scope presets that are pre-configured to look at something are usually not how you want to look at it. So here are voltage and time settings, 500 millivolt per division or 1 volt per division. We talked about this. I want to be able to see at least system voltage, and then I can shrink down from there. Time settings, we see 5 milliseconds per division for medium speed, 50 microseconds for high speed. Wait a minute. What if I don't know what I'm working on? Let's start with 50 milliseconds. Let's get something happening. It may look like noise, and then I can zoom in from there. Circuit access, DLC or whatever's easiest. So it really depends on if it's a DLC network or not. If it's a DLC network, go to the DLC. But what if it's not a DLC network and I want to see activity on that network? Can I go to any module in that network to see what the activity looks like? Because it should be the same everywhere, shouldn't it?
Yeah.
And if it's not, then we know we have a problem. If I have good communication at my test point or a good signal at my test point, I can go back to the wiring schematic, figure out what can't be wrong. If I don't have a good signal at my test point, then I know I'm on the bad part of the network. And again, I can go back to the wiring schematic to help find out what's wrong. So here we have a Honda with a medium speed body network, BCAN network. Is not connected to the DLC. So we looked at the wiring schematic and we decided that the sun load sensor or module was the easiest to get to. So we popped it out of the dash and back probed it there.
And what, interrogated the network from your scanner or would you?
Yeah, so we back probed it, hooked the lab scope up to see the network activity. Because if I can't talk to some modules or can't talk to any modules, is the network even talking? Is it shorted or open? I got to start somewhere. Might as well start with the easiest module. And we can see here where it is on the schematic. And this is a parallel network. Here's their jumper block. So if the jumper block was easy, we could have gone there. In this case, this was the easiest place to go. Then who can I talk to? Who can I talk to? Do I have a good signal here or a bad signal here? The point of the slide is just to get you thinking out of the box. Go to the one that's easiest. Get a scope pattern there and compare it to the wiring schematic to figure out what has to be good and where your next test point needs to be. Here is normal activity on that network. 2.5 volt bias and goes positive and negative. And you see it's mirrored. So even though this is not what anyone would call a square wave, this is about a 5.3 millisecond message. So we don't have the detail if I wanted to look at that, but unlike a lot of things, we're not overly concerned with detail here most of the time because we have a mirror image and our eyes pick up very quickly when something's not mirrored. So I'm not so concerned with, is the square wave square and is all this perfect? I'm looking for, does it look the same high and low? Because if it doesn't, bingo, there's something going on. Using a different scope. Again, looks very different. Same test. So what does normal look like on my scope? And here we're looking at 50 microseconds on the screen, 500 microseconds, excuse me, on the screen. So what looks normal on my scope? Don't compare my Snap-on scope to an ATS or a Pico. They're going to show it a little differently. And this has to do with sample rates, filters, shielding on the leads, what speed options I have on the scope. I mean, so there's quite a few things that go into what it's going to look like on my scope.
How about the LCD display?
Yeah, exactly. How much computing power do I have? How good's the display? All those things. But does this follow the rules? Does it mirror each other? Can we see?
Yeah.
Right, that's the whole point. So here is a dedicated CAN network between the PCM and TCM on an 03 Cadillac. We used a 1 volt bias in the scope. That's where you see one go from 3.5 to 4.5 and the other one 2.5 to 1.5 because we actually added a volt to it in the scope. So the ATS, instead of having different scales, you add voltage to the different patterns to separate them out.
Does that actually put voltage in the line or is it do it
No,
internally?
just on the screen.
It does it internally in its own
Yeah.
circuitry.
On the
Okay.
display, exactly. Just biases the display a volt. So these are both at 2.5 volts for the bias. One goes a volt high, one goes a volt low. This has less activity because there's only 2 modules in the network. Here is medium speed CAN. And whoa, I got a 7 volt bias. Well, wait a minute. I'm only supposed to have a 2.5 volt bias. Bingo, that's a problem. Then, but what I look here is what happens. It comes down and tries to talk and then goes back up. So I've got a bias, but what? We have enough voltage drop in the bias that I'm able to pull it down to that 2.5 to 3.5 volt range when we want to communicate.
So you're saying this is good?
No, this is bad.
It's short to power, right?
Short to power.
Yeah. Yeah. So it's communicating the normal range, but I have a short to power, not battery power, but some power. Obviously through some resistance, because it was a dead short, then we wouldn't be able to pull it down to talk.
Could you run around and unplug modules if it was easier since it's an older car and see where this?
Yeah. Or you could do research to find if it's normal, which is not on this car, but so, you know, again, so you can, and you may get no communication here because it doesn't like it. So here's the GLAN negative signal doing the same thing, trying to toggle to talk from that 7 volt bias. Communications in the normal range, but I got no communication with the system. because it doesn't like what it's seeing. And yeah, you'd have to go around and disconnect to see where the problem is. In this case, it happens to be a bad EBCM ground or ABS module. So here we have an ABS module with a bad ground. Bad ground elevates voltage, right? And that's what it was putting on the network. So yeah, your only choice is to what? Go around and start unplugging stuff. Because we know it's going through something because it's not a dead short. It can't be a wire that's chafed. Because there's some kind of load here which allows it to move. So next up, I have a winner, a 2008 Mercedes C300, no start, no mill, no communication, melted main fuse box. Ignition switch and shifter module are both bad. Fuse box, ignition switch, and shifter module have all been replaced. The mill works, but the car won't crank. Still have no communication. There's 3 networks at the PCM, 3 different CAN networks. CAN I is a dedicated network with 1 other module, so that's probably not our problem. So it makes sense. So let's look at the other 2 networks. And that's CAN C and CAN E to see what's going on. So what I'm looking at here is 2 different networks, not 2 legs of the same network. But do either of these follow our communication rules? How's that bias voltage look?
High.
High and this, right? Is that a flat line between those communications?
No, it's got that curve again.
Got that curve. And that's true on what? Both of them. So it can't be a single network fault. It has to be something that both networks have in common. If it was a single network fault, one network would have a nice flat line, the other one would have the wavy, right? So there has to be something that both networks have in common.
Ground.
Ground, and then where does the ground come from? It has to be a module that's on both networks, correct? Because if the module was only on one network, it probably wouldn't be affecting both of them. So the PCM happens to be on both networks and we're already there. So we disconnected the PCM and it didn't look like this. So we decided to take a look-see inside the PCM. How do those 3 ground connections look?
Oh yeah. It's kind of hard to see in the book.
Yeah, the PowerPoint slide should make it a little easier. But yeah, someone jump-started their car backwards. What I will tell you is I've seen this on Mercedes twice now.
I just see the different color of the leg.
Right, you can see the different color of the leg, and if you look closely,
It's
this
smoke.
is completely open.
Oh, okay, got
This
it.
one's melted and open, not quite as big, and this one has definitely gotten hot and started to melt.
Right.
This is the second Mercedes I've seen this with from jump starting backwards.
So basically the PCM shorted and burned.
Yep. Yeah, they jumped it backwards, and apparently that's the fuse. That's an
Well, you need bigger wire. It needs 8-gauge wire there. That's the problem.
yeah, the hard wire here that I just pointed to. Yeah, the hard.
No, we need to put 4-gauge wire in there. That's
okay, yeah.
Yeah, that's the problem.
Yeah, that's right. Just put a bigger fuse in.
Yes, yes.
Exactly. That's an expensive fuse, isn't it?
Yeah, I could never understand why they got all these fail safes, but they never put one on for battery backwards.
Yeah, some manufacturers do. Some manufacturers, you blow that 120 amp fuse and nothing else happens. But no, it's amazing how many of them don't have other protections in there. And of course, this is a cheap car. You know, it's only what, an E series? Oh, it's a C. Yeah, I guess if you bought the S class, you'd get some better protection. I don't know. No, this is the second Mercedes I've seen of this vintage. Jump backwards, exact same thing in the PCM.
Yeah, that's why they decide not to jump it, just hold to the dealership. That's
Yep.
what they mean.
Yeah, but what does the AAA guy do? He talks him into jumping it every time.
Yeah. And then they diagnose right on the lot for the customer.
Right.
Yeah.
And then when the smoke does come out, they tell you how jump started. There's nothing they could have done, and they didn't try to jump start it before they.
Yeah.
took it.
Most of
Well-
AAA guy, they diagnose it for the customer, and then the customer come and tell me that, oh, AAA guy tell me this is bad. Okay.
Yeah, oh, I know. I had to call AAA last year, almost a year ago, and it's amazing. The guy trying to sell me a battery on a car that I left the lights on with a 1-month-old battery.
Yeah.
Just, well, I don't know if we can jump start. Just get it started. Oh no, I got this, and trying to give me the full sales pitch. Just jump start.
Yeah, because AAA, they have two different guys, one for the tow and one for the service.
Yep.
And the one for the service, they come, most likely they try to sell the battery.
Yes, they do.
Yes.
Even when it's only 1 month old, says interstate on it.
Yeah. And
Well, if you really find yourself, they have the state California tow truck. I don't know
Yeah.
if you're familiar with a Sandag.
Yep.
They're fairly sharp. They're
Yeah, that's-
decent.
that's a roadside assistant for
They're
the
not
state-
there. They're not there to sell you anything.
No, they're not.
Yeah.
Because he doesn't sell anything, and
Right.
they're pretty decent. They're old. You know, they're not up to date like us, but I mean, they're pretty decent. They're all old mechanics. I had a flat tire about 2 months ago, and one came out and
Okay.
put up traffic cones and a whole shit. So you know, it was cool.
They there for help people.
Well, you can call them. Yeah, you can
Yeah,
call
the
them.
call boxes.
Yeah, you can call them. It's sometimes probably better than doing AAA.
Yeah. Okay, so 2000 Silverado, no crank. Towed in with a no start complaint. Lack of dash lamps, no bulb check, no park neutral display. Scan tool could not communicate with the PCM, TCM, or BCM. So the customer interview revealed that leading up to the no crank, the lamps, gauges, door locks had been operating erratically. The technician didn't check all the codes, so it's possible and likely that additional modules had codes. But the no crank, just because it's network case study, technician checked the starter and starter relay, but when a GM BCM cannot communicate, you don't have any starter because the BCM controls the starter on these trucks. So here we did a quick lab scope check of the high-speed CAN, which is connected directly to the DLC. How's this look?
Well, it's always got voltage when it's supposed to be at rest.
Yeah, where's our bias voltage at?
That's gone too.
It's high, isn't it?
Yeah, around 8 volts, I guess.
No, we're not that high. What are we at? My
6?
yellow is at what, a little over 3? Because my voltage scale's here, so bias
okay.
voltage is a little over
All right.
3. And my green scale, again, a little over 3. We're supposed to be at what, 2.5? So if I have high bias voltage, that's a sign of bad ground.
It's hard to see in the book.
Yeah, that's why I got the slides up. Not that they're
I know,
all.
I was looking in the book. I said 8, and I was calling 8.
Yeah.
It was 3. That's 3.
Gonna need to get a set of these.
I guess so.
So isolating the bad ground. So the wiring diagrams not shown were checked to find that the only junction connector used in this network wasn't very central, so it wasn't easy to get to. From there, the CAN lines travel to the BCM, and then out to the TCM, the power steering module, and the powertrain control module in series. Based on this structure, it made sense to cut out the data lines on the output side of the BCM, and then it didn't seem like such a good idea. So while still on a test list, it seemed like a less drastic step back and determined that all these modules had in common and test that instead. Common ground, the ground distribution wiring diagrams were checked, not shown, and each of the non-communicating modules shared at least one ground through G103. Connects to the front right cylinder head, which is easily accessible. The bolt was checked and found to be tight. However, the ground wires looked aftermarket and were connected to a snowplow, not a California vehicle, and accessory lights, and other accessories. What about the grounds from the OEM harness? They were found tucked between the intake runners. Once the grounds were reattached, everything worked. So how did this thing run with the grounds just laying on the engine? Apparently it was enough to keep starting the car until it wasn't.
What? Who would pull the ground off from the back? Jesus, that's a lot of work.
Yeah.
To hook up your snowplow, who would pull that ground?
Apparently somebody did. What amazes is who's lucky enough to have it start afterwards when you don't hook the computer ground back up. Not me.
Oh, they made a good design though.
So here is a capture of what it looks like if my CAN positive is shorted to voltage. So CAN plus is at system voltage, so it can't move. My CAN negative also sees system voltage. However, since it goes through the two terminating resistors, when it tries to talk, we will see it pull itself down. We're still not going to have any communication, but we can see that by this pattern that my short to power has to be on the positive side of the circuit because the negative side's able to move. At rest, they're both at system voltage, but my negative side is able to pull down because on the negative side, we pull from 2.5 to 1.5, we pull down. On the high side, it pulls from 2.5 up to 3.5. It's pulling up. We're already at system voltage, plus there's no load there. It's not doing anything. So this is what CAN positive short to voltage looks like. Now we can compare this to CAN negative short to voltage. Both circuits are high. They both stay at system voltage and neither one of them really moves. Because on CAN negative, I have a dead short with no load. I can't pull it to ground. And CAN positive is trying to pull it high. 1 more volt, we're already at 13 volts. Where are we going to go? So you see that little hiccup there, but there's obviously no communication. This is what it looks like when the CAN negative is shorted to power. So we can do a bunch of resistance tests and connection tests, or we can hook a lap scope up. How about if CAN positive is shorted to ground? So here we have 0 communication. Both are going to have a bias voltage of 0 volts, and CAN positive can't toggle high because there's no load. It's shorted, so it can't go anywhere. And CAN low, what? Toggles low, we're already at 0 volts. Where are we going to go? So we may see some noise. There is no real communication. On the other hand, if CAN negative is shorted to ground, nothing happens on CAN negative, but we see here where CAN positive tries to talk by pulling the voltage from 0 up to 3.5 volts. So with 4 lab scope captures, I can already tell you if I have a shorted CAN, whether it's shorted to power, shorted to ground, and whether it's the power, the positive lead or the negative lead of the CAN side. Is that a lot of information for one scope check at the DLC using your new breakout box?
Yeah.
Again, why would I be checking terminating resistance? It makes no sense. I'm going to hook a scope up to it because if my CAN is shorted to CAN, between the modules, either a shorted terminating resistor or the lines are shorted, the bus stays at 2.5 volts because all I'm doing is coming this, but wait a minute, we're kind of doing this, so we're really not doing anything because they're shorted together. So if CAN shorted, no communication, and here's what we look like, and if you notice, we're not inverted. Here's CAN negative open circuit. So here we have a CAN negative open circuit. I can see the module that I'm on trying to talk. That's the big negative in the middle, but I have none of the other traffic. So I have an open and my negative between where I'm at and the rest of the circuit. And that's why my negative doesn't look like my positive, because I'm on the open side of an open in the negative CAN circuit. Here's open terminating resistor. Cycling in the same direction, no communication, more erratic than normal. Not all look this way. It may try to go to single wire mode, which I'll show you, but again, you can see where we're moving here. This is what an open terminating resistor looks like. So a shorted terminating resistor, that's my line shorted together. No activity at all. Open terminating resistor looks like this or something close. Again, why would I depower and everything else and get an ohm meter out? And then maybe I have 0 and gee, is this really a problem? Or the intermittent or, terminating resistors? Do I have more or less terminating resistors? Or I can just hook up a lab scope up and see what the pattern looks like, and that's going to give me a direction. I think this is more information for less work.
So just set up 2-channel lab scope and then take a look on the
Yeah, 6 and
CAN.
14. Yep, 6 and 14 on the lab scope. And what do you have?
6 and 14.
Yeah, 2 and 10's old Ford. You're dating yourself.
Okay, so bias voltage is the same on both lines. 2.5.
Yeah. Right?
And CAN positive wants to pull up and CAN negative wants to pull down.
Yep.
All right.
So here is a 2012 Camry. Post-accident systems. Lots of lamps are on. Steering wheel sits there and shakes to the stop. Only the immobilizer and occupant classification modules talk to the scan tool. The vehicle drove into the shop. And they don't even have any codes. So as we look at this, we figure out that our ISO 9141 is good, which is the 2 modules we can talk to, and that CAN is dead. But yet the PCM to TCM have a separate high-speed CAN, which probably explains why the car, as far as engine and transmission, drive normally. We don't have any power assist steering and the lights lit up, dash lit up like a Christmas tree. But this is a parallel system, meaning that I have what? Junctions I can unplug things from. So let's throw a lab scope on it. So we've identified the system. Let's look at our lab scope. I got no communication. What does this pattern tell me? So CAN positive and CAN negative. CAN negative is at 0 volts all the time. CAN positive is at 0 volts at rest and goes up to 3.5 when it tries to talk. So am I open or shorted?
Shorted.
Shorted.
And negative is shorted.
Ground.
CAN negative is shorted to ground. You got it. So I have a car I can't talk to, drives, hook the lab scope up at the DLC. I know what I'm looking for. I have a shorted CAN negative wire and that's shutting down my whole network. So to diagnose that, I need to what? Isolate the legs of the network. So I have these connectors that I see in the wiring schematic. I got one here and one here. And which one do I go to first? The one that's easiest to get to. Right? People always ask me, where do you start? The one that's easiest to get to. So here's the connector. And what do we start doing? We keep our lab scope on the network and we start unplugging these guys. If I unplug them all and I still have a problem, I got to go to the next connector, right? So as I'm unplugging, hey, we now look like this. And I can talk to things. Did I just find which leg has the problem?
Yes.
Yeah.
Yeah, absolutely. So Trigger Networks has specific wire colors for each leg, so the offending circuits were easy to identify. Connector with the white and yellow wires was disconnected from the right junction connector and the right side kick panel, and everything worked to normal. This went to the brake actuator controller, which makes sense since that controller was located near the accident damage. So the body shop apparently pinched something during the work, and new wires were installed. Old stuff was cut, installed a new twisted pair, and everybody's happy.
Body
So it was
shop.
just the wiring. It wasn't the module.
Yep.
The wires
They pinched
after the
wiring
accident. Yeah.
in the accident, and the body guy didn't catch it.
Yeah, body guys is always.
Yep.
So that's where visually you might have caught it if it's something that's exposed.
Exactly. Depending on, in this one you didn't see it was pretty buried, but
Yeah.
we didn't want to start taking back off the front clip. But yeah, a lot of times you can see this stuff visually. I mean, how many times do body guys get wires caught when they're putting panels back together or things? I mean, it's all kinds of stuff gets screwed up by body guys. They run
Yeah,
screws into wires. They do all kinds of neat stuff.
Yeah, they throw a lot of things too.
Yes. And they're the smart ones. Just ask them. So fail safe. So if a dual wire communication isn't possible or isn't stable or is impossible, then single wire communication, while it's not as good, is better than nothing. So some manufacturers support a single wire fault mode that'll turn off the bias and independently cycle each circuit. The idea is that with the circuit isolated from each other, then one of them has a good chance of getting through with the message. So we can see here on the left is a capture from a Volkswagen where it's telling us, hey, we're in single wire mode. On the right is a Dodge Magnum that is telling us, hey, you 1107 ECU in single wire mode. So we can have, more than one manufacturer does this. In this case, we were diagnosing a U0019 and code UU1107 was set during testing. So we're wiggling to isolate. And we had the scope leads hooked up and we're wiggling it. And here's what it looked like when it went from 2-wire mode to single wire mode. So you see where we're inverted. And then all of a sudden we see the red do a shift and now they're the same. So we went from 2-wire mode, we're inverted, to single wire mode, we're both the same. What we figured out is we were causing the problem. This network didn't like the scope hooked up. We were using a picoscope and it didn't like the picoscope, and the difference